Hello my dear students, after successfully finishing the segregated part of equilibrium, that is chemical equilibrium, in our previous lecture, let us now build an edge over many of the students because most of them leave ionic equilibrium because this chapter is generally spiced up with the common ions produced by both strong electrolytes and weak electrolytes. Difficult to understand? Just hold on and allow me to explore and reveal this beautiful chapter to you, because this chapter was initially loved by advanced, but since around 2019-20, mains have also started inculcating those exact concepts. So this chapter will also improve your JEE-AIR and will also help you during advanced questions. And do not worry, because I have personally curated only those specific questions and topics which are highly probable for JEE Mains examination. Do not worry to write those lecture notes because you can obviously download them for free from our PW app, the link to which is given in the description section, because PW is the largest organization loved and trusted by millions of students, and they give results to the best of their efficiency. So let's explore this side of equilibrium.
So to begin with, when rate of forward reaction becomes equal to rate of backward reaction, that state becomes the equilibrium state. When this state is achieved by molecules, equilibrium is molecular equilibrium. But when this state, rate of forward and backward reaction, becomes equal, this state is attained by ions called an ionic equilibrium. Who furnishes ions? Electrolytes. What are electrolytes? Which can dissociate completely in water. If completely, strong electrolytes. If partially, weak electrolytes. But if at all I dissociate, I am an electrolyte. Generally, the electrolyte which we see are acids, bases and salts. So let us define these acids and bases first. Acids and bases were first successfully described and science community accepted the concept of Arrhenius. Arrhenius simply said, which we know through 9th standard, that acid is a species which furnishes H+ ion in water, right? Of any mineral acid, HX, a strong acid, because it completely dissociates. How do we know that? Through the value of equilibrium constant K. If all those species who are strong electrolytes, their equilibrium constant K will be having a value which is much larger than 10 raised to the power plus 3. So HX is a strong acid, or any mineral acid is a strong acid because it completely dissociates and furnishes H+ ions. Sir, we know H+ is just a bare proton. How it is existing in water? No. Practically, H+ does not exist as H+. Actually, it interacts with water molecule and form the hydronium ion. And what are bases? Bases are species which, when dissociates in water, ionizes in water, forms the hydroxyl ion, the basic definition. Bronsted modified this definition because there were various molecules which were not having H+, not having OH-, but still having acidic nature. What Bronsted modified, actually Bronsted and Arrhenius has the same logic for acids. Bronsted also said acid is a species which furnish H+ ion in water. But it modified the definition for bases and said bases are species which accept H+ ions, which accept protons, like ammonia. Ammonia does not have OH. So how can you say ammonia is a base? Arrhenius cannot define that, but Bronsted defined it. Bronsted said ammonia has a tendency to accept H+ and form ammonium ion. I am giving you another example. For example, HCl, when present in water, forms hydronium ion and Cl-. Sir, this is forward reaction. Every reaction is reversible. It will come back also. We very well know, as I said, HCl is a strong acid. So we know that this reaction will largely exist in forward direction. So what Bronsted said that, Bronsted and Lowry said that HCl is an acid because it is furnishing H+ ion. And after furnishing H+ ion, it is becoming Cl- ion. Similarly, water is a base over here because water is forced to accept H+ ion from given by HCl. So water accepting that H+ ion becomes a base and forms a conjugate acid of hydronium ion. If reverse reaction is taking place, although I know it will take place to a very negligible extent, but for that negligible extent also, if at all it is taking place, what Cl minus is doing? So Cl minus is accepting H plus, so becomes a base. But what base? Conjugate base, because it is given this Cl minus was born by HCl. So acid forms conjugate base and base forms conjugate acid. If reaction is moving largely to the forward direction, that means who is doing their job with highest efficiency? Acid. So this acid is a strong acid. Therefore, its conjugate base will be a weak base. This base cannot accept H plus ion to larger extent because its counterpart is a strong species. Rather, if I take another example and I say CH3COOH, we very well know organic acids are weak acids. If this is present in water, then this, why we write aqueous? Whenever anything is dissolved in water, it's called an aqueous solution. So when this acetic acid dissolved in water, we can definitely find these ions. What are these ions? The acetate ion and the H plus given by acetic acid goes to water forming hydronium ion. So you tell me, who is acting as an acid over here? This is acting as an acid because giving H plus. Water is accepting H plus, so acting as a base. Acid, when going forward, the counterpart that it forms, if it is an acid, this counterpart is called its conjugate base. Similarly, this is a base accepting H plus, so its counterpart will be called its conjugate acid. Now, over here, as we know, mineral acids are strong, so its equilibrium was acting to the forward direction. So if this acid is strong acid, its conjugate base is weak base. Similarly, if I'm saying if this acid is a weak acid, that means it is not moving forward. That means its counterpart is strong because that counterpart is strongly moving back. So if that is a weak acid, then this acts as a strong conjugate base. So this is conjugate acid base theory, that if father has done really good, then generally the son performs not that good. I'm not generalizing. This is just through the Bronsted-Lowry concept. Moving ahead. Okay, now finishing this, after finishing this Bronsted-Lowry concept, it also had some limitation. There were many acids, many bases, which were not lying in this definition as well. Who are those acids and bases, sir? That definition and those examples was explained by the final theory, which is valid till date, which is Lewis concept. Lewis said acids are species which can accept electron. And this definition literally covers all the definitions that were given previously of Arrhenius and Bronsted. Arrhenius said who are acids? Giving H plus. If I'm giving H plus, why? Think of the electron transaction. If I'm giving H plus, I'm definitely accepting the electron pair of hydrogen. So yes, and couple up with the other examples. For example, Lewis definitely explained what Arrhenius and Bronsted did. This is an acid, this is an acid. Why acid? Giving H plus? No. If you give H plus or do not give H plus, you are accepting electron. Chlorine over here is accepting electrons. CH3COO minus over here is accepting electrons. So if you accept electron, you are an acid. Similarly, there are other examples as well, which they cannot explain, but Lewis did. How? AlCl3, BF3 also have acidic nature. They do not have H plus. How can you say they are H plus? They have a tendency to accept electron. And generally, these people give H plus ions only in water. But these species are indifferent. They can act as acids even if there is no presence of any solvent. So, how Lewis explained, see, AlCl3, BF3, people said okay. Lewis explained they have incomplete octet. They said right. They belong to almost the first and second period of periodic table, hence they are very electronegative. People said yes. Electronegative species, if do not have complete octet, is deficient of electrons. People said yes. So they can accept electron. So whoever has incomplete octet of central atom and are highly electronegative, they can accept electron. Hence AlCl3 and BF3 in many of their inorganic reactions act as a Lewis acid. Similarly, all the D block cations, because D block cations are generally electron deficient, they have D block, and if they get positive charge, they will all have a tendency to accept electron and fill those electron in their D orbitals like these. Even P block elements with having positive oxidation state and also having their empty D orbital can also accept electrons, and hence they can also behave as an acid. Even other molecules like carbon, sulfur, if they acquire positive oxidation state when they are attached via multiple bonds, to whom? With an electronegative atom like oxygen. Because oxygen can form multiple bonds, they will make multiple bonded oxygen will make that element so electron deficient that they will also have a tendency to accept electron. Like CO2, SO2, SO3. Over here, what is the oxidation state of CO2? Sir, +4. Highest positive oxygen, hungry of electron, hence you see some reaction of CO2 as acting as an acid. SO2 +4 state, SO3 +6 state, hence when these gases are dissolved in water, they make water acidic, forming carbonic acid, sulfurous acid, sulfuric acid, hence acid. Lewis said, who are bases? If you are accepting electron, who is giving you electron? If I am getting 100 rupees, somebody has to give 100 rupees. So bases are those who are donating those electrons. Arrhenius said bases are those who give OH minus ion. How you give OH minus ion? You give OH your electron. Sir, covering that definition also. Bronsted said, who accept H plus, why H plus will come to me? Because I will give him electron. So Lewis theory explained previous definition also, and there were many bases. F minus, Cl minus, Br minus, they do not have OH minus. They are negative anions, but because they can donate electrons, so they can also act as a base. This cyanide ion, mind you, in cyanide ion I have definitely therefore drawn its covalent structure. Carbon also has electrons, nitrogen also has electrons. Both can be donated, but which lone pair will have a highest tendency to be getting donated? Carbon. Why? Because this minus is signifying that I am having excess of electrons. So what will flow? Excess or limited? Excess. Moreover, carbon is relatively electropositive. Then nitrogen. So nitrogen will keep its electron to itself and will force carbon to donate. So in Cn minus, what is the donor site? Which atom donates electron and acts as a base? Carbon of cyanide ion. Similarly, ammonia we have seen. If I connect this ammonia with an alkyl group like organic amines, 1 degree, 2 degree, 3 degree, they can also be a base. Alcohol and oxygen, lone pair are present, alcohol can also act as a base. Water, we have already seen, because of presence of lone pair, can act as a base. Moving ahead to sir, we have discussed much about water. Why? Because we know every molecule has a tendency to dissolve in water, because water is a universal solvent having a huge amount of hydration tendency. So discussing about water, some people also say, sir, water also give H plus and OH minus, and no. Water is not an electrolyte, we should keep in mind. Many of us will be knowing that also, but it involves a beautiful chemistry in its dissociation. Let us understand that beauty. Yes, we can never neglect this property of water, yes, although to a very, very, very small extent, but water also has a tendency to generate small amount of H plus and OH minus. Not greatly, but limited. Although this tendency is very limited, but this tendency has a very useful, practical, and during our calculations for our JEE questions, this ionization property of water will be saving us a lot. How? First, we understand this. Let us say at 25 degrees Celsius, sir, temperature have to be mentioned. Yes, every equilibrium, if temperature changes, equilibrium changes. The value of K, which is an equilibrium constant, which do not depend on the concentration of any of the reaction mixture species, but it depends upon temperature, the Van 't Hoff equation we have done in the chemical equilibrium side. So you have to always define an equilibrium at a particular temperature. The particular temperature I'm using is 25 degrees Celsius because question is generally framed in this 25 degrees Celsius, that is 298 Kelvin. So if I have water, let's say at time t equal to 0, concentration of water is C and this is 0 and this is 0. For simplicity, I'm taking this concentration to be 1. Why? Because sir, equilibrium constant K do not depend upon the concentration of the reaction mixture. So let us assume 1. Let's say you have 1 moles per liter of water dissociating. Initially, it is not. At equilibrium also, it is negligibly dissociate. It will be dissociating negligibly, but we are just assuming what is the negligible amount. Can we calculate it? Let's see. So let's say if X molecules of water dissociated, X and X are produced because stoichiometry is 1:1:1. Now, if this X is a concentration, we have gone to the mother nature and did experiment and calculated H plus. How much you are getting produced by water. We saw that this value approximately came out to be 10 raised to the power 7 molar. What is molar? Molarity, moles per liter. As in, if 1 liter of water is present, then the H plus it is furnishing is 10 raised to the power minus 7. What is definition of molarity? Molarity is moles per liter. So, if you have 1 liter of water, how many molecules, how many ions of H plus you will be having? 10 raised to the power minus 7. So obviously this is negligible, but still we are focusing on this value because if it is also X, then this is also X. So water is a neutral solvent because it furnishes H plus ion equal to OH minus ion. Now we very well know that this condition of equilibrium is represented by equilibrium constant K. If we write this equilibrium constant for this ionic equation, it will be concentration of H plus ion at equilibrium into concentration of OH minus ion at equilibrium upon concentration of this H2O. Now, what I am doing theoretically is this is a constant and we know concentration of water, if so many molecules of moles of molecules are present, but out of that, how many molecules have dissociated? 10 raised to the power minus 7. So it is a negligible amount. So almost the concentration of water, what it is taken, it is also a constant. So a constant into another constant, to these two we multiply and we write it as Kw, which is the ionization constant or dissociation constant of water. And again, because it is nothing but equilibrium constant, so its value will remain the same. You add acid in water, you add base in water, you add anything in water. Does the value of equilibrium constant depends on the concentration of species? No. So this value will remain the same. And so what it will be? It will be equal to concentration of H plus ions into concentration of OH minus ions at equilibrium. Do we know this concentration for H plus and OH minus ion at 25 degrees Celsius, 298 Kelvin? Yes, sir. What the value is? 10 raised to the power minus 7. So 10 raised to the power minus 7 into 10 raised to the power minus 7 becomes 10 raised to the power minus 14. This value is very important. I'm pairing it 5 times. Remember this. Now, because water is a neutral solvent, you tell me what is the concentration of H plus ions? So 10 raised to the power 7 minus 7. What is concentration of OH minus ion given by water? So 10 raised to the power minus 7. We designed a scale to quantify the presence of H plus ions in water called the pH scale. So we say, what is pH? It is minus of logarithmic value of to the base 10. If I'm writing log, it is to the base 10 of the H plus ions. So at 25 degrees Celsius, pH will be equal to minus of log of what is H plus ion, sir, at 25 degrees Celsius by water. it is equal to 10 raised to the power minus 7. So value of pH, we know the property of log. If not, go to chemical equilibrium playlist. I have explained everything over there. Then start this. 10 log of a raised to the power b is b log a. So this minus 7 and this minus will become 7 and value of log 10 is 1. So water is a neutral solvent. So we started saying is if pH of a solution is 7, then this solution is a neutral solution for us. Even you add any acid, any base, any species, if they are maintaining by whatsoever reason, if they are maintaining a pH of 7, then that solution is known as a neutral solution at 25 degrees Celsius. Remember, if H plus ion concentration start getting increased, let's say it reaches 10, what is increased? 10 is power minus 7. What is a value larger than this? 10 is power minus 6, minus 5, minus 4. So obviously, if that value increases, 10 is power minus 6, minus 7, minus 5, minus 4, value of pH will decrease. So if pH is 7, it is neutral, and if it is decreases, the solution becomes acidic. If it increases, the solution becomes basic, because through the concentration of H plus ion, and this definition we know. Now, next thing is, can you tell me if temperature increases, what will happen to the value of Kw? Sir, if temperature increases, the water molecule which was not dissociating at all, if temperature increases, this bond will also get that extra energy. And because of supply of that extra energy, some more molecules will be dissociated. Oxygen being electronegative will take electron, furnishing H plus. So some more molecules will be breaking up. So if molecules are broken, the dissociation increases, and because the dissociation increases, the dissociation constant will also increase. So with temperature, value of Kw increases, you should keep this thing in mind. Now, moving forward. So on moving forward, we reach to Ostwald Dilution Law, which says any electrolyte, whether you are strong, you are weak, if you are present in water, if your amount decreases, then I as water can make you completely ionize. How, sir? Let me explain this to you. This is really important, so bring your focus. Suppose I have an acid HA. This HA, when introduced in water, we know it dissociates, giving H plus ion and its conjugate base A minus ion. At time t equal to 0, let's say its concentration is C moles per liter. Initially, nothing is formed. We know what is degree of dissociation, moles dissociated upon moles taken initially. Let us say the degree of dissociation of HA is alpha. So at equilibrium, what percentage it will dissociate? Alpha percentage. Alpha percentage of what? Of the amount initially taken, C. So how much it has dissociated? C into alpha. Let's say if 100 molecules are there and dissociation constant is 5%. So if 100 molecules are there, dissociation is 5%. So what is 5% of 100? Sir, 5 into 100, 5 into 100 upon 100. Because how will you calculate 5%? 5 upon 100 is 5% of what? Of this 100. So therefore you will get 5, no? So keeping that logic, if C was taken initially, so C into alpha. What will be alpha? Anything. If it is 5%, the value will be 0.05. So C alpha. If one molecule gets dissociated, or better to say ionized, because ions are forming 1. So if C alpha dissociated, it will be C alpha, it will also be C alpha. Can you write equilibrium constant for this? Yes, sir, we can write. Because it is an acid, so I am writing it as a dissociation constant of acid. So this K becomes Ka. What is this Ka dissociation constant of acid? Sir, concentration of H plus ions into concentration of A minus ions upon concentration of HA. Mind you, because we are writing value of equilibrium constant, it does not depend on these concentration, but when this ratio of their concentration are taken at equilibrium, this becomes equal to K. At any point, this value is called reaction quotient. This ratio is called reaction quotient, and at equilibrium, this reaction quotient Q becomes equal to K. So we write it. And these concentrations we have already taken. So what are these concentrations? We put those values. So C alpha. So numerator becomes C square alpha square. C square alpha square upon, if this is denominator, C taking out common, so getting cancelled. So this is 1 minus alpha. So basically K is equal to C alpha square upon 1 minus alpha. C I have already cancelled. Now I am asking you, what is this electrolyte, sir? If it is a weak electrolyte, I am now giving it a condition. If electrolyte, if I'm writing over here, if electrolyte is weak, if HA is a weak electrolyte, that means it dissociate very partially, 5%. Anything that dissociate 5% or less is a weak electrolyte. That means, sir, alpha is very less than 1. If alpha dissociation is close to 100%, it is 100 upon 100 is 1. So 100% dissociation is 1. Strong electrolytes, generally, nobody dissociate 99.99 because definitely they'll reach equilibrium. But if it is weak, when less than 5%. Less than 5%, then alpha mathematically is very less than 1. So if alpha is very less than 1, then what you can approximate, in the theory you can say that you will not write 1 minus a very small thing. We will, while doing mathematics also, we will assume it to be 1. Let's say if you have a denominator of 0.99999, you will consider it as 1 and then do your mathematics. So theory is saying what you approximate while doing into divide, you approximate theoretically. So this denominator becomes 1. So what this equation turns into, sir, Ka becomes equal to C alpha square. So what becomes the value of alpha? Alpha becomes under root of Ka upon C. Now I am defining C. Let us say this concentration, this molarity is 1 moles of electrolyte you have dissolved in V liter of solution, because what is definition of molarity? Moles per liter. So if I am taking 1 moles of solute present in V liter of solution, this will be the value of C. Put this value of C in equation 1. So value of alpha becomes under root of Ka into, if C is 1 by V, then what is 1 by C? 1 upon C becomes V. So this is under root of Kv. I teach my students and make them remember it as under root of Kendriya Vidyalaya Kv. So this becomes under root of Kv, and a very important conclusion, which is also showing you, which is also making you learn this logic, that as V, what is V, sir? Sir, can you restrict somebody to use this volume? I have to use 1 mole electrolyte. This is what I have assumed. So if that 1 mole electrolyte is present in a very large volume, or proportionally you can decrease moles also. You do not take large volume, sir, we take test tube. So even if for an ant, this much of water can drown that ant, that small ant, red ant, black ant, that small species, even this much of water is sufficient for them so that they can drown. So if you take very small moles of solute, even this much of water or test tube of water is infinitely large for them, they can drown. So what I am saying is, if number of moles of solute added per liter of solution, if this volume is large, then this V increases. As this V increases, alpha increases. So what theoretically Ostwald did is, it termed this volume as not volume but dilution, that is increasing volume. So if I increase volume with respect to moles of solute, the degree of dissociation also increases. The degree of dissociation or ionization also increases. So even a weak electrolyte having small alpha can be forced to completely dissociate when you increase the volume, that is dilution. So this is Ostwald dilution law, that even you are an acid, you're a base, you're a weak acid, you're a weak base, I can force you to dissociate more if I increase the volume. Instead of increasing the volume, I'll not take room full of water. I'll take this limited water also. I'll put very small number moles of electrolyte. So even a weak electrolyte can dissociate completely if dilution increases. This is Ostwald law. Moving to the next slide. So moving forward, if let's say you are asked dissociation constant of water. Sir, for water, what we have read is the ionization constant, or some people call it this, which we did, is the ionization constant of water. Answer, it is represented as Kw. But you are saying dissociation constant of water. Actually, look at the difference over here. This equilibrium constant K, somebody calls it ionic product of water because, sir, concentration of water remains the same, because the number of H plus and OH minus ions that water H2O is furnishing is negligible. So this constant into this constant becomes a new constant, and that constant we term as Kw, the dissociation constant of water, which is simply the ionic product of water. The ions that water furnishes, the product of that is known as ionization constant. But if somebody is treating water as H plus, if the questionnaire is treating water as H plus and asking you this value, then equilibrium constant, if used for a water, is also called dissociation constant of acid and represented as Ka. Similarly, for a base, it is this equilibrium constant is also termed as Kb, the dissociation constant for a base. This A and B is suffixed, is actually subscribed, like over here it is subscribed. This K written as a smaller a version is subscribed. So this is also, sir, equilibrium constant. How will we calculate it? Through common sense. Sir, what common sense? The common sense which we did in mole concept and chemical bonding. We very well know A if term, then we are considering the tendency of water to give H plus. So this equilibrium constant will be equal to the H plus and OH minus ion concentrations at equilibrium upon this H2O concentration will also has to be substituted. Sir, the value of numerator, this we know. How do you know? This ionic product is always a constant. Keeping in mind temperature is 25 degrees Celsius, we also know if you change the temperature, it will again be a constant. But that value will change because K will change. So Kw will change. So at 25 degrees Celsius, we have learned this value. What this value is, my friends? It is 10 raised to minus 14. Sir, you said this concentration of water will remain constant. Yes, but you have to place that value of constant. Sir, how will we know concentration of water? You have to supply that value. No. Go to the common sense of mole concept. Concentration is molarity. If you need to calculate molarity, how do you define molarity? Number of moles of water, because you have to calculate concentration of water per liter solution. So I am killing one variable just like mole concept. I am taking volume to be 1 liter. So if you have to calculate this molarity of water, I have to put moles of water, and water is the solution only. So volume of solution is 1 liter. So can you tell me, if water present is 1 liter, what is the number of moles of solute present in water? Yes. How? Because for water, it is known, and if you do not know it, then you should remember it from now, that density of water, although in mole concept I have discussed, it is always 1 gram per ml. Practically, this volume is at 4 degrees Celsius, but generally we take volume of density of water to be 1 gram per ml. Sir, if density is 1, then mass of water can be equal to volume of water. 1 liter is 1000 ml into density 1 gram per ml. So this gives you the weight of water. So for 1 liter of water, you know the weight. So what will be number of moles? Moles is equal to weight upon molecular mass. So this molarity you can easily calculate by putting formula for moles, which is given mass on molecular mass upon volume is 1 only. And this value you all should remember. This value is 55.55 moles per liter. Using this value over here, yes sir, we can definitely calculate the dissociation constant of water. And because over here you are directly, you have to divide it also. So why putting this value? I'm just asking you to remember this value. But for ease of calculation, I'll use 1000 upon 18 because 18 will go to the numerator. So it will be 18 into 10 raised to power this minus 14, and this minus 3 will make it 10 raised to power minus 17. So see, you can also see you can also look at the ratio like this. If you have, what this ratio is, if you have at equilibrium, just see to this ratio and feel the ratio. If you have this concentration of water at equilibrium of 10 raised to the power 17 molecules, so your great grandfather has a property of, has a bank balance of 10 raised to power 17 rupees, crores and crores of rupees. And of that crores, how much you got? What is, after multiplying concentration of H plus and OH minus, and what they got 18 rupees. So crores and crores and crores and crores and crores, and you got 18 rupees. You got good share, right? So now you tell me, do water dissociate to form H plus and? Sir, it is actually negligible. You will, if in those crores and crores and crores of rupees, you will be getting 18 rupees, you got right share, no? Obviously, you got nothing. So the ionization is nothing but the value of K, which is 10 raised by Kw, which is 10 raised by minus 14, will never change because equilibrium constant do not depend upon the concentration of species. If you change concentration of species, Q will change, and Q will again try to reach K. Q changes, K never changes. We will use this for calculating other questions. Now moving ahead, I will do some basics and then we'll directly shift to the actual questions, whatever asked in ionic equilibrium. We'll make it very precise, whatever object-oriented mains is asking. Now, but some basics issues. So I'm just finishing basics first. What is common ion effect? Suppose I have an acid. We all generally know, if you do not, we all generally know, if you do not know it. Generally, all mineral acids are strong acids, completely dissociates. Organic acids are known to be weak acids, like acetic acid. So it's a weak acid, it will dissociate 5% or less. So if you take 100 molecules, I'm just taking an example. If you take 100 molecules, initially no one has dissociated. Let's say its dissociation is, a degree of dissociation is 5%. So out of 100, 5 will break. How much is left? 95. 5 got. So 5H plus, how do you calculate K of this acid? K of this acid will be concentration of products, ionic products, upon concentration of the reactant. This value will remain the same for acetic acid at a particular temperature. Okay. And how many H plus ion it is giving? 5. Okay. So acetate ion 5. Now, I again have this solution, acetic acid. But now I have introduced a salt into it. You should always remember this: salt, until unless specified, is always a strong electrolyte, dissociate completely. What is until unless specified? In this chapter only you will see some salts are sparingly soluble, and because we already know from chemical bonding, that we'll do later chapters also, that some salts have got covalent character. Because their covalent character increases, so they do not ionize. So, but in general, if not stated, generally salts are strong electrolyte. So if you have taken a salt, it's a strong electrolyte. If 100 molecules taken, almost 100 will dissociate. Almost 100, some bit. No reaction reaches completion, they reach equilibrium. So, but the value of equilibrium will be so large that we can say that approximately all have dissociated. So, I'm approximately taking 100 of this and 100 of this has formed. Now, if both of these equilibrium are existing together, so 100 of acetate ion and 100 of Na plus ion already there in the solution because it is a strong electrolyte. It will not see to anybody else. It is an extrovert person. If it has gone to a party, it will say whatever it wants to. So it has dissociated how much ever the salt wants to. Sir, it's a weak acid furnishing acetate ion. So you can see the common ion from the salt and from the acid. Now, apply Le-Chatelier principle that we studied in chemical equilibrium. Sir, for this equilibrium, if you see, if this salt would not have been there, how much ions were formed? 5 if they were present individually. Now, what I am doing by adding this salt, I am increasing the concentration of this ion, which is the product for this equilibrium. When the concentration of product increases, the dissociation, the equilibrium will shift in backward direction. Sir, I was already a very weak electrolyte, and because of presence of common ion, my dissociation will become more and more and more negligible. So if it was alone, 5 of this were dissociating. Now I do not know, some 10 raised to minus will be dissociating. So how much it will be dissociating, I do not know. Let us take it x. Some x will still be dissociating. So if x is dissociating, then what would be remainder of this reactant? 100 minus x. How much it will be produced? X. How much it will be produced? X. And this x value will be much lesser than the value that was dissociating when common ion was not present. That is 5 in our case. Sir, can you calculate this x? X. How? Value of equilibrium constant never changes. So whenever equilibrium will shift to backward direction, but still some x will be dissociating and reaching equilibrium. So at equilibrium, what will not change? This K value. Even if it was alone, the K value will be supplied. So moving forward, what we have is, you have to derive a relationship between dissociation constant of acid Ka and dissociation constant of base Kb. But this K and Kb are dissociation constant, but of whom? Of not any acid and any base, of conjugate acid base pair. This is also general knowledge of equilibrium that you should know. Sir, conjugate acid base pair, Bronsted-Lowry, we discussed. So according to Bronsted-Lowry, who is an acid? Let's say ammonium ion is an acid. When goes to water, what is an acid? Which furnishes H plus? It furnishes H plus. H plus is just a bare proton. So technically, what should I write? Water taking that H plus, forming hydrogen ion, and this is ammonia. So if I'm giving H plus, I'm what? An acid. So this becomes my base, conjugate base. I'm again writing the equation for this base. What is a Bronsted base which accepts H plus? Ammonia, when dissolved in water, accepts H plus from water, forms ammonium ion and hydroxide ion. So these are conjugate acid base pair. Let us write K and Kb for these conjugate acids and bases. How, sir? You tell me how ammonia is acting over here as a base. So for this equilibrium constant can be written as dissociation constant of base. So for this, because it is acting as a base, so this equilibrium will be termed as dissociation constant of this base. It is equilibrium constant only, but theoretically it can be nomenclatured as Kb, which is dissociation constant of base. Write the equilibrium for constant of this. It will be concentration of product upon concentration of reactant. I am telling you this again and again. These all concentrations are the values at equilibrium. K do not depend upon these values. Yes, the ratio in the numerator denominator changes, increases, decreases, and arranges in such a way that when disturbed, they again reach equilibrium and their ratio always becomes equal to this because they follow this. So concentration of product upon what is reactant, concentration of ammonia, and although concentration of water remains the same because concentration of pure liquid and pure solid do not impact the state of equilibrium, but still I'm writing. So over here, ammonium ion is acting as an acid. So this equilibrium constant will be written as dissociation constant of this acid, Ka. What will it be? Sir, it will be concentration of ammonia into concentration of hydronium ion upon concentration of ammonium ion into concentration of water. So this is your as base, this is as acid. Multiply both of them. Ka into Kb. Can you see what is Ka into Kb? Ammonium ion from numerator, denominator get cancelled. I just do that so that we do not write one more step unnecessarily. We can do that in mind. Concentration of ammonia from here, numerator, from here, denominator got cancelled. What are you left with? Sir, we are left with concentration of H3O plus. H3O plus, we know because H2 is just a bare proton, but H3O plus we can write as water and H plus ion. Concentration of OH minus will also come to the numerator. And in the denominator, I'll be having these H2O squared. This and this will cancel. Can you see this is H plus OH minus upon concentration of water. Concentration of water, as I said, this is again a constant. So, or you can also say that, sir, it can be neglected. It is assigned to be unity because its concentration does not change. We have recently seen out of those 10 raised to power minus 70, 10 raised to power plus 17 molecules, how many broke? So, this is a constant. So, removed. So what you got is concentration of H plus into OH minus. This is ionic product of water, the ionization constant of water. That is, this value is the value of Kw. So just put this thing in your mind, a very important conclusion, that for conjugate acid base pair, Ka into Kb is always equal to Kw for conjugate acid base pair. Take negative logarithmic of this value. So minus of log of K into Kb, what is property of log? Log A into B is log A plus log B. So it becomes, or I can say minus of log of Ka minus of log of Kb becomes equal to minus of log of Kw. Why doing this, sir? Because there is one more relationship which you should know. Just it's a glimpse of eye that we have to do. What is minus log function, sir? It is P operator. What was pH? Minus of log to the base 10 of H plus ion concentration. So what will be minus log of Ka? It can be written as pKa plus, because this minus has to be taken as the P operator, plus pKb equals pKw. What is value of Kw? 10 raised to power minus 14. So what will be pKw? 14. Yes, but it is equal to 14 only at what? Only at 25 degrees Celsius. This I have repeated much of the time. Moving ahead. Yes, so moving forward to some actual calculations which are actually asked in JEE, we are starting with the pH calculations. So for example, the first case that we are starting with are pH of strong acids. So what is a strong acid? We very well know strong acid is a substance which has alpha degree of dissociation approximately 100%. So let's say at time t equal to 0, we are supplied with let's say C molar. This is the concentration, the molarity of the acid. It will be given to you. I have taken a acid which can furnish any number of H plus ions. It can be 1, 2, 3, like HCl will furnish 1, H2SO4 will furnish 2, H3PO4 will furnish 3. So initially there are no ions, and after, when equilibrium is reached, it will be approximately gone, completed, or some amount will be left, but because we do not have to find K. In order to find K, we have to know the denominator, but we just have to calculate the pH. So H plus will be approximately whatever acid was present. But sir, if one molecule dissociates, how many H plus ion it will furnish? n number of H plus ions. So this will be Nc because approximately all the C moles are dissociating and it will be C. So what will be the concentration of H plus ions? Sir, concentration of H plus ions will be equal to Nc. So remember one thing. What is normality? Sir, normality is equal to molarity into valency factor. And what is the valency factor for acids? For acids, it is equal to the number of H plus ion they furnishes. So therefore, can't you see that, sir, this is nothing but normality? Why? Because molarity into valency factor. So for strong acids, we can just summarize that for strong acids, pH is definitely equal to minus of log of H plus ion concentration. And in place of this H plus ion, we can directly take the normality of the acid given to us so that we cannot write this reaction all the time. We can just do this on a head and can definitely find pH. How to do that? Minus of log of what is normality? Molarity into valency factor, which is N, and we'll take this value. For example, the acid given to us is H3PO4. What is its concentration? 10 to the power minus 2. So I will directly write pH is equal to minus of log of concentration, the molarity, which is 10 to the power minus 2, into valency factor, which is 3. Applying the property of log of A into B is log A plus, because this is minus, so it will become minus log B. What is log of A to the power B is B log A. So this minus 2 when multiplied with minus becomes 2 log 10 minus log 3. Log 2 is 0.3, log 3 is 0.48, approximately taking as 0.5. So log 10 is 1, so 2 minus 0.5 is 1.5. Answer. Obviously, see, temperature is not mentioned, so we will always take 25 degrees Celsius. If mentioned, they will definitely tell you what becomes the value of Kw. If temperature increases, dissociation of water increases, so value of Kw increases, so it will be not 10 to the power minus 14, it will be minus 13, minus 12. If temperature decreases, value of dissociation constant decreases, so it will be higher, it will be lesser, that is 10 to the power minus 14. What is lesser value? Because it is minus, so minus 15, minus 16 are lesser values. Now, 10 to the power minus 6 molar HCl, how will you calculate? Again the same thing, sir. pH is equal to minus of log of normality. Normality is molarity into valency factor is 1. So this is directly 6 because log 1 is 0. You do not have to write 1 also. So, sir, why you are telling this again? Sir, see, you are approximating one thing also. Sir, you are not all these acids furnishes H plus in water. Sir, water also furnishes H plus. You have not considered H plus given by water. We very well know the H plus that water furnishes is negligible. But sir, still we know that the value is 10 to the power minus 7. So we have diluted, although it is a strong acid, it will completely dissociate, but it is so dilute that its concentration is approximately reaching to that furnished by water. But for water, its value is 10 to the power minus 7. It is 10 to the power minus 6. So you will say, sir, it is there is only a difference of 10 times. If it is 10 to the power minus 6, that is 10 raised to the power minus 7. Okay, it will giving 10 rupees. It will give from water, it will give 1 rupee. So, sir, 10 plus 1 will become 11. Why you are writing this? You are cheating? No. Why? Remember common ion effect. I agree. When HCl is present, it will completely dissociate and form, although its concentration is very dilute. So, how much it will give? 10 to the power minus 6. If you simultaneous equilibrium, which we have studied in chemical equilibrium, if simultaneously water is also dissociating, I have not writing equilibrium sign because strong acid completely dissociates. But if water also dissociates, if it was dissociating independently, then its concentration will be 10 to the power minus 7 furnished by water. But in presence of common ion, because this ion will definitely be present in this much amount only because it is coming from a strong acid. So don't you understand this, that if it was 10 raised to the power minus 7 when it was alone, in presence of this common ion, concentration of product is increased. So this equilibrium will proceed to backward direction. That means the value of H plus furnished by water will be much lesser than 10 raised to power minus 7. That's why I'm neglecting it. So it is not even, if it is 10 rupees, it is not even 1 rupee. That's why till the dilution reaches the level of water, which is 10 raised to power minus 7, you can always neglect the H plus ion coming from water. But sir, if it is so dilute that it reaches the constant dilution of water and even lower it may go, then you have to consider water. Sir, how will? See, there are two methods. One is definitely the approximate method, which is easier to do. So if you have options which are far apart, you can do this approximate method. So what is approximating? What is the approximation? Like if you have HCl, we very well know it will furnish H plus and Cl minus ion, and this amount will be completely this 10 to the power minus 7, because it is a strong, it is indifferent if you are present or not, I will furnish. But for water, I understand it also furnishes H plus ions. Even considering because of presence of this common ion, its dissociation will be suppressed. But the ion that HCl is also furnishing, the concentration is very less. So even if it proceeds in backward direction and dissociating lesser than 10 to the power minus 7, but since this value is very less, we can say it will be lesser than 10 to the power 7. But approximately, let us take 10 to the power minus 7 only, although it is not right. It must be some lesser value. But since this value is only very less, so what lesser value can do? So let us, I'm again saying it is an approximate method. It is not, whatever we are doing is not correctly right, but for options we can, sometimes it's work. So you tell me, what is the H plus ion concentration at equilibrium? The one given simultaneous equilibrium, this plus this. So this will be counted. So it will be 2 times of 10 raised to the power minus 7. So my pH will be equal to minus of log of 10 raised to the power minus 7 into 2. Again applying property of log. 10 to the power minus 7 becomes 7 minus log 2 is 0.3. So this is 6.7. Yes, but this is approx because the H plus given by water is lesser. It is not 10 to the power minus 7. So obviously H plus given by water is lesser to this. So when we calculated exactly, this value will be something higher because H plus, we have considered more H plus. So pH must have gone much lesser than 7. It will be somewhat greater than 6.7, but obviously lesser than 7. Let us calculate what it will be. So doing exactly, we can definitely say H plus given by HCl will be 10 raised to the power minus 7, but for water, according to Lee-Chatelier's principle, equilibrium must have proceeded in backward direction. But still, some of the water will be dissociating. How much? I do not know. Let's say that value is X. Finally, again, when the equilibrium reaches, some of it will be dissociating. Let's say X. So this will be X. Applying simultaneous equilibrium, so concentration will be 10 to the power minus 7 plus X, not 10 to the power minus 7. So if you now calculate the value of pH, it will be equal to minus of log of 10 raised to the power minus 7 plus X. Sir, how will we calculate the value of X? One thing never changes. What? The value of equilibrium constant, which is Kw for water. For this we do not know, but for this we know. Dissociation constant of water. Temperature not mentioned in question, take 25 degrees Celsius. So this Kw, whose value we know is 10 to the power minus 14 because it's the equilibrium constant, it will be equal to concentration of H plus ions at equilibrium into concentration of OH minus ion at equilibrium. So what is concentration of H plus ion? If that is considered there, so this will be also considered over here. So you tell me what this becomes. Sir, we can see a quadratic equation because H plus ion concentration is this and OH minus ion concentration is this. So it will be X square plus 10 to the power minus 7X minus 10 to the power minus 14 barabar 0. Do Sridharchar method, X is equal to minus B plus minus B square minus 4AC upon 2A. Do that. I know you can do that at least. So we are being time efficient. So once you will calculate that x and put that x and mathematically calculate it, that is your homework. The value will come out somewhere around 6.79 C, greater than 6.7, greater than 6.7, but definitely lesser than 7. So before moving forward, you must be having this question in your head. Sir, you just explained that we have to calculate and account the H plus given by water also. But over here, during these questions, like over here, I have accounted the H plus given by water. But while I am discussing strong acids, why I was not accounting them? I'm just concluding this. Whenever the H plus ion given by acids are large enough, so large enough as in they are large, that is, acid is dilute, but till 10 raised to the power minus 8. As we have seen, what the pH we got? 6.79. So what is the pH of water? Sir, 7. So if the acid, although strong acid, but if acid becomes so dilute, let's say post 10 is for minus 9, minus 10, the H plus given by them is so small that the pH is obviously just decided by water only. But water will have no problem if the H plus given by acids are much larger, then water has no role to play. It will be not accounted. Now, coming to mixture of strong acids, same is the case. Whatever questions you get in JEE, I mean, when strong acids case are asked, the concentration is large enough, so you do not have to account for water. If you have to account, I've already told you the common sense. So, if you have mixture of acids, sir, for acid we had to calculate normality. So for mixture of acid, you calculate total normality. Sir, how to calculate total normality? Total normality will be, what will be the H plus given by first acid? Sir, N1, V1, because I'm not interested in number of moles. I am interested in number of gram equivalent, because I do not have to then write the reaction. The valency factor will be taken into account by number of gram equivalent. And what is the form of number of gram equivalent that we are using over here? Normality into volume, because molarity will be given, like molarity is given. So molarity into valency factor into volume of first acid, plus the other one will also furnish H plus. So N2 V2 of the other one upon, but now this mixture has a total volume of this also, that is V1, plus this also, that is V2, plus water, because water will increase the volume, but the H plus given by water is not counted. Why to add that 10 raised to minus 7, which is much lesser, because these common ions will not allow H plus from water to be furnished. So this is what you can definitely do. Once you get normality, the value of pH will be minus of log of the normality total that you are getting. Easy case. Sir, why not solving this? That's a practice for you. You can definitely do it. And whatever I have given, I have taken water also, which will, this V3 is volume of, water, because I'm adding water. But these volume are in ml, doesn't even matter. These will be milligram equivalent, so milli will get cancelled. So you can directly put this value. So moving ahead, sir, this is a question I told you from after pH calculation. I said that this is what is asked in JEE. For example, you are asked with 600 ml of 0.1 molar HCl is mixed with 400 ml of 0.01 molar H2SO4. Again, what you have to do is number of gram equivalent of this, which is N1 V1. What is N1? Molarity is 10 raised to the power minus 2. Valency factor is 1. Volume is 600. So these will be millimoles. What about it? So again, molarity is 10 to the power minus 2. Valency factor of H2SO4 is 2 H pluses. Into volume is 400. So this is just easy case. This is 6. This is 4 into 2 is 8. 100 is gone. So what is number of milligram equivalent? So what is total normality? 8 and 6 is 14 millimoles upon volume. Sir, here water is not taken. So the mains have asked you even easier question. 600 and 400 is, this is 1000. Why taking 1000? Because volume has to be, sir, because in the numerator also we have placed volume in ml. So this volume we also have to place in ml. So milli will get cancelled. So 1000, that's why I've taken. So this is normality. So what will be the concentration of H plus ion? This only, 14 into 10 is power minus 3. So what will be the value of pH? So pH will be minus of log of 10 raised to the power minus 3 minus of log of 14. Log of A into B is log A plus log B. This is simple property of log 3. Here you have to, some log values are given. So how can you write 14? 14 is 7 into 2. Log 7 given? Yes. Log 2 given? Yes. Although log 11 is given, but it is not required. So you just do this calculation and check whether what answer you are getting. Yes. So I guess the value that you have provided, log 7, 0.84, log 2, 0.3. If you will solve it, it will be 1.86 because answer you have to report as 10 to the power minus 2. So it will be 186. Moving ahead, a simple piece of cake question. If theory known, actually it is piece of cake. Again, same question, HCl. So it's a practice question for you. We told you, you will not have to go anywhere. Practice also we will be giving. These are all the questions that are asked at JEE. Okay, this let us solve. This is not a JEE question, but a different type. I mean, some mathematical skills may be required. So equal volume you have taken. So let's say volume is V. HCl solution. Okay, both are HCl solutions. So valency, both are giving 1 H plus. So pH of first is 3, of second is 5. And you have to calculate the resulting. Now, the volume, normality, volume, concentration, they are not given. They're directly pH is given. So what is pH? Minus of log of H plus. So if this value is minus of log of H plus is equal to 3. Can you tell me what is H plus ion concentration? Sir, it will be minus 3. And using property of log, this is log base to the log to the base 10. So what will be H plus ion from this? It will be 10 raised to the power minus 3. What is H plus ion from this? 10 raised to the power minus 5. So this will be normality of first. This will be, I mean, the H plus ion given by first one and the second one. So what is H plus ion concentration? Because it is H plus ion concentration, so it will be the normality given. Normality of first and normal. Now the question is of the same type. Normality given, volume given, both volume are V. Again do what? Sir, H plus ion concentration total will be, you told us, N1 V1. So this is N1. What is volume? Assume a V because it is, the question is saying it's equal volume. Into 10 raised to the power minus 5 into V upon total volume becomes V plus V 2V. Same formula. Just the pH was given, so you have to calculate normality first. Okay, some mathematical skills. V coming out, getting cancelled. It is 10 to the power minus 5. So what can you do with it? You can write it as 100 into 10 raised to the power minus 5. So this is nothing but 1 into 10 raised to the power minus 5. So 10 raised to the power minus 5 comes out to be comes out as common. 100 plus 1 is 101. 101 can be approximated as 100 only. 101 into 10 raised to the power minus 2 upon 2. 100, because we know if it is 100, it can be easily solved. So considering to be 100 dividing by 2, I'm getting somewhere around 50 into 10 raised to the power minus 5, or simply 5 into 10 raised to the power minus 4. Now calculating pH for this. So what is pH? What will be pH? So pH will be minus of log of the H plus ion concentration, which is this, the overall normality. So this is 5 into 10 raised to the power minus 4. So it comes out to be 4 minus log 5. What is log 5? How I remember. Log 2 is 0.3, prime numbers. 3 is 0.5. 5 is 0.7. So it is 0.7. So this is 3.3 option. Now moving ahead. Now, sir, simply for strong acids we calculate. How can we do for strong bases? We very well know H plus into OH minus, every H plus and every OH minus will be furnished by the strong acids and strong bases in water. Although you are not taking the contribution from water for either H plus ions, for either OH minus until the concentration of these strong acids and strong bases reaches its territory of 10 to the power minus 7. We will not take contribution of water, but because all these equilibrium are taking place in water, you can take help of the value of Kw of water, because that never changes and is independent of the concentration. So how to? I'll give you. NaOH also gives Na plus and OH minus ion. If it is a, let's say, if it is a base giving 2 or 3, so again, whatever you were doing for strong acid, do for base, but base gives OH minus, so that calculation will become the concentration of OH minus ion at equilibrium will be equal to the normality of solution, the total normality, the mixture of bases, everything for strong acids. Just whatever you were getting was the concentration of H plus ion. Now you will be getting concentration of OH minus ion, simple, just the difference. Sir, but if we know OH minus ion, we are asked pH. OH minus ion concentration will come out to be normality. So molarity 10 to the power minus 2 into valency factor. So this is OH minus ion concentration. If you know OH minus ion concentration, do you know all these reactions are taking place in water? And for water, I know H plus ion concentration at equilibrium given by whosoever. OH minus ion concentration given by whosoever. When multiplied, it is equal to 10 raised to the power minus 14, because temperature is not mentioned. So Kw we will definitely take at 25 degrees Celsius. You can also use this equation for your calculations, and sometimes you can also take minus log. So pH plus POH will be equal to minus of log of this is 14. So you can use either of the equation. You just calculate this OH minus ion, you either take minus of log of OH minus ion, it will give you POH. Subtract it by 14, you will get pH. Or this 10 to the power minus 2 is given, you directly put over here. Like in this case, this will be much easier. Minus 2, so it will be minus 2. So if minus 2 will be gone in the denominator, it will be minus 12. So H plus ion will be minus 12, the pH will be 12. Moving ahead. Sir, this question also came. Yes, try it. The question says millimoles of, okay, now you are asked millimoles of calcium hydroxide required to produce 100 ml of aqueous solution. Okay, pH is given and you have to find this value of X. That what are the millimoles? That it is the same question. Just we have to keep in mind what is the base, calcium hydroxide. So valency factor of calcium hydroxide will be 2. So if it is a base, what will be the concentration of OH minus ion given by this base? Sir, it is equal to normality. Normality is equal to, what is its valency? Okay, its concentration is not given, its pH is given. So the pH is given out to be 12. So sir, if pH is given out to be 12, then we know pH plus POH is equal to 14. So what will be the value of POH? Therefore, sir, I can say POH is equal to 14 minus 12 is 2. That means I can say OH minus ion concentration is 10 raised to power minus 2. Because this is minus of log of OH minus ion is 2, then OH minus ion at equilibrium is 10 raised to power minus 2. Sir, what is concentration? Normality. What is concentration? Normality. So normality is 10 raised to power minus 2. What is normality? Sir, it is equal to molarity into valency factor. So now we know molarity. Are we asked molarity in this question? No, sir. What are we asked then? Sir, we are asked number of moles. So molarity becomes equal to 1 by 2 becomes 0.5 into 10 raised to power minus 2. I hope you can see the answer. So if molarity is this, are you asked molarity? No, sir. So let's write its formula. Number of moles upon volume of solution. it's a 100 ml solution. So if I'm writing molarity, I have to put volume in liters. So in order to make 100 ml liter, I'll multiply 1000 in the numerator, because over here it will be divided, so going up. So this comes out to be 5 into 10 raised to the power minus 3, because this is 0.5. I'm moving one decimal to that side. So this is getting cancelled. So n becomes 5 into 10 raised to power minus 3, and this 10 makes it minus 4. So these are the moles. What are you asked? Millimoles. So in order to make it a millimole, this is 5 into 10 raised to power minus 1 into 10 raised to power minus 3 moles. And what is milli? 10 raised to power minus 3. So this becomes millimoles. What is your answer? Sir, my answer is 5 into 10 raised to power minus 1. And it has to be reported in this case. So answer is 5. Moving forward. Now, sometimes in order to calculate pH, you again have to take what? Mixture sometimes are given. But mixture of strong acid and strong base is given. What to do, sir? Calculate, do not calculate number of moles, because somebody will give 1, somebody will give 2. Although easy question comes, but still I am giving you the best possible scenario. So first you calculate number of gram equivalent of acid. How to do that? Don't calculate moles, calculate gram equivalent. What will be number of gram equivalent of acids? Let's say 2 or 3 or 4 acids are given. N1 V1 of first plus N1 V2 of second plus so on. You will be having number of gram equivalent of acids. Those component that will be giving H plus ions. Then calculate number of gram equivalent of bases. If acids gram equivalent are more than bases, we know H plus and OH minus ion will attract each other and form water. So whatever ions will be remaining will be deciding the concentration. So let's say if number of gram equivalent of acids are more, let's say if it comes out to be 100 and it comes out to be 50. So out of these 100 H plus will come, 100 OH minus ion will come. H plus OH minus ion will react. So what will be remaining? Sir, 50 H plus. So 100 minus 50, but remaining are H plus. So what concentration will be giving H plus? So the 50 moles or 50 gram equivalent upon total volume. Volume of all the components, volume of water also if added. Although water will not contribute to H plus, but will be added as volume will be increased. Sir, if OH minus ion comes more, then whatever concentration you'll be getting is for OH minus ion, but then it will be number of gram equivalent of base minus acid. Sir, this is a very, give us example, JEE acid, but a simpler case. I've told you, I'm giving the best case. You have to calculate pH obtained by what? Obtained by mixing 50 ml of HCl and 30 ml of 1 molar NaOH. So you tell me what is number of gram equivalent of acids that you have? Sir, normality is molarity into valency factor HCl is 1 into 50. Okay, it is number of milligram equivalent. Let us take ml only, because number of milligram equivalent upon volume will put in ml, so it will be cancelled. So can you tell me number of milligram equivalents of base? Yes, sir. Sir, it is. Molarity is 1. Valency factor of NaOH is also 1. And volume is 30. Sir, it is easy. So who is remaining? Sir, it is 50. It is 30. Who is extra? Acid is extra. So what will be left behind? Sir, acid will be left behind. So what will be the active ion present? Sir, H plus, not OH minus. How much H plus will be remaining? Sir, 50 was given by HCl, but 30 was neutralized by NaOH. So 20 are remaining. Upon V1 plus V2, what is its volume? 50 plus 30 is 80. I am putting it in ml only, because milli will get cancelled. Milli. So this H plus ion comes out to be 2 by 8 or simply 1 by 4. I can take minus log of this, but some value is also given. Whenever data is given, be precise with the data. Take 2.5. Am I getting 2.5? Yes. 1 by 4 is how much? 0.25. So it can be written as 2.5 into 10 raised to the power minus 1. So what will be pH minus of log of H plus, which is this. So minus of log of 2.5 into 10 raised to the power minus 1. Log of A plus B, this minus and this minus will become 1 minus log of 2.5. Now it's just a maths for you. Log value is given. You put that value of log and subtract it. You will get your answer. So moving forward, we have discussed about strong acids and strong bases. Now coming to pH calculation of the weak counterparts, the weak acids and bases. First, I am considering weak acid. Let's say HA is a weak acid. Now, I hope we all remember what we remember. Sir, any acid or any electrolyte can be termed as a weak electrolyte if its alpha degree of dissociation or degree of ionization is less. For strong counterpart, it is around more than 90-95%. For weak counterparts, the question wanders around mains and advanced, the point of difference for mains, for JEE mains and advanced. Generally, the weak electrolytes that are supplied to us is generally mains ask whatever electrolyte they ask, the weaker one, they have a degree of ionization of less than 5%. So let's say if I have 100 rupees, 4 rupees, 3 rupees can be easily neglected. But a value more than 5% will force you not to do approximation, because now that 100 plus 6 rupees, 7 rupees has to be considered. So first I'll be speaking just for mains where degree of dissociation, degree of ionization is always less than 5%. So let's say at time t equal to 0, the concentration you are supplied of the weak acid is HA. Initially, no ionization obviously. At equilibrium, let's say alpha is the degree of ionization. So C minus C alpha, because C alpha of HA has ionized, 1 dissociated, forming 1 and 1. So forming C alpha and C alpha. Can you write the dissociation constant of acid of this acid Ka? Yes, sir. Concentration of product upon concentration of reactant. Mind you, what concentration? Sir, only equilibrium concentration, because Ka has nothing to do with these value. At equilibrium, the ratio becomes equal to K. I have been repeating it many times. So can we put this value? Sir, why not? Definitely yes. So let's do that. In numerator, you will get C alpha for HA, then C alpha for A minus, and in the denominator, you will get C minus C alpha. Just simplifying it, very easy to do, I guess. K becomes equal, C get cancelled because taken out common. So 1 C would be remaining. So numerator becomes C alpha square, denominator becomes 1 alpha. Now I am approximating. What? I am assuming theoretically that alpha is very, very less than 1. If degree of dissociation is less than 5%, let's say it will be 1 minus, for example, 0. Let's say it's 4%. So 1 minus 0.04. What will be the denominator? So 0.96. While calculating also, 0.96, you take 1. The fluctuation in the answer is not much. So do that theoretically. So if alpha is very, very less than 1, why it is so? Because acid is weak acid. But mind you, when you should do this, we will do this when alpha is actually less than 5%, or value wise alpha is less than 0.05, because here what alpha we have taken is upon 100. So it is not 5, it is 5 upon 100, the percentage value. Okay. So if it is so, 1 minus alpha can approximate it to be approximately 1. Variable killed from denominator. So from here, you can have the value of alpha. So what does alpha becomes? A becomes C alpha square, because this has turned into 1. So C alpha square, so alpha becomes Ka upon C whole under root. Now, sir, why you are calculating alpha? Because generally K and concentration is supplied to you in the question. So you tell me what is our job? Our job is to calculate H plus ion at equilibrium. What is H plus ion concentration at equilibrium? C alpha. So C into this alpha we recently calculated. So this comes, C goes into the square root, so becomes Ka into C. Bingo. So this is a relation which I recommend all of you to learn by heart. This is your H plus ion concentration, and H plus ion concentration is under root of Ka into C. I can even serve you with another relation which will be easier to learn. Since H plus ion concentration we have derived as under root of Ka into C. So one form you can also learn, so that can be applied to the question directly. Taking minus log on both sides. So minus log of H plus ion concentration will be equal to minus log of Ka into C raised to the power 1 by 2. Remember the properties of log. What is it? Sir, minus of log of H plus is pH. Directly pH you can calculate. Just to save time, I'm just giving you another form. Log of anything raised to the power A raised to the power B is B log A. So 1 by 2 will be coming as a multiplier, half of. Now, log of A into B is log A plus log B, but there is a minus, so I'm multiplying this minus log C. Sir, minus of log of K can also be written as pK. Definitely yes. So the formula becomes half of pKa minus log C. Some of my students even love to learn this formula as well. So you can learn this conclusion that for V counterpart, it is equal to half of pKa minus log C. Sir, but although for mains, I guess this much is sufficient for you to understand, to remember. I mean, I suggest you should learn this. Don't derive it all the time. But for good questions, what you can do is you can calculate alpha easily. Suppose you have approximated. Let's say you have approximated. But still you can have this value. After this approximation, you had this value. Before moving forward, just put the value of K divided by C and take its under root if the value is coming out to be greater than 5. Sir, then degree of dissociation, although it is weak, but it is more than 5%, then you should not approximate. Then sir, what shall we do? Do the basic. What is the basic, sir? This is the basic. Then this denominator will not go. So how will you calculate alpha? It will become a quadratic, just like we have done for water. It will become a quadratic. So solve this quadratic, which will require your mathematics. After solving that quadratic, you will exactly get the value of alpha. If you have got that value of alpha, now still H plus ion concentration is C alpha. C is provided to you. Now after solving that quadratic, the C alpha will be the final H plus ion concentration. Again, there is a catch. If that C alpha that comes, if C alpha that you calculate, if its concentration, if its value, because its concentration of H plus ion is even less than or maybe equal to 10 raised to the power minus 7 molar, then again, one, it is a weak electrolyte. The amount of H plus it is giving is now has become equal to the amount of water. So now again, water also have to be accounted. So again, you have to do what? H plus given by weak acid is this. H plus given by water is obviously in presence of common ion, it will dissociate to less extent. Let's say that value is X, which we have done with strong acids. So again, still now H plus given by water is, let's say X. It will not be 10 raised to the power minus 7 because of common ion effect. Dissociation of water has also been decreased. Just the same thing. So if this is a case, then from acid also you have to consider and water also you have to consider, because this acid is now very dilute also. So what is H plus coming from this acid? C alpha. What is H plus coming from water? X. Everything changes, but one thing never changes, which is now use again Kw of water. So Kw of water is H plus ion concentration. This into OH minus ion concentration. Water is dissociating to an extent of X, becomes equal to 10 raised to the power minus 14. Now solve X. Again a quadratic. After getting this X, what will be your final H plus ion concentration at equilibrium? So C alpha plus X. So alpha you have also calculated using quadratic, X you have also calculated using quadratic, then sum the value and then minus log will give you the value of pH. In advance such questions are asked. Mains never ask those questions. Never, I should not say. Mains, although few times, but you can always use this formula. Just you have to check whether alpha is less than 5% or not. 98% of the time it will work because the weak acid that they give is less than 5%. Dissociation is less than 5%. Sir, what about weak bases? Nothing, same. So for weak bases, again the same analogy like we have done for the strong counterpart. Base will just, instead of furnishing H plus ion, will furnish the hydroxyl ion. So its concentration will be C minus C alpha at equilibrium. It will be C alpha. So whatever you have been doing for H plus ion, that will be done for OH minus ion. So directly I am saying, because for weak acids you calculated pH, so the same value will become for pOH. So pOH will be half of pKb, because dissociation constant of base is Kb, minus log of the concentration of the weak base given to you. So this will be your formula. Sir, but we are asked pH of the base. pH plus pOH is equal to 14. So pH of this solution will be 14 minus pOH. So for bases also, you do not have to do anything else. It is just the same thing which we have been repeating for strong acids. So now let us see how JEE checks us about what we have read just now. You are given a acid, butyric acid. It's an organic acid. Organic acids are weak acid. The formula is also given. It's an acid containing 4 carbon. The K value dissociation constant is given. With the value of dissociation constant also you can see, sir, acid is weak acid. pH you have to calculate and concentration is given out to be 0.2. So first, I told you, mains these days they give you an acid whose alpha, but let us check whose alpha is definitely less than 5%. But just check in the side once. So what is this alpha? Under root of K, it is given out to be 2 into 10 raised to the power minus 5 upon what is C? Sir, it is 0.2. So this is 0.2. A 10 comes to the numerator, so 10 raised to the power minus 5 becomes minus 4. So minus 2 comes out of square root. 2 got cancelled. So this is what? This is simply 0.01 C. 1%. So you can easily apply the formula. I have to calculate pH. What will the value of pH? Remember, half of pKa minus log C. So half of pK, because K is given, so minus of log of 2 into 10 raised to the power minus 5 minus log of 2 into 10 raised to the power minus 1. So just do this, half of, so what is minus log of A into B is log A plus log B. So we can directly put the value. Log 2 is also given. We also have learned this value. So what is log 2? 0.3. So minus 0.3. This minus and this minus will become plus. 5 comes over here. Log 10 is 1. Minus again log 2. So it is also again 0.3. Then minus minus plus. 1 comes here. Log 10 is 1. So this is half of 5 plus 1 is 6. 6 minus 0.6 is 5.4. Divide by 2, so 2.7. So our answer is 2.7. Okay. This formatting always check in JEE questions. This is, you have to report as 10 raised to the power minus 1, so it will be 27. Now, sir, generally this works as I have told you, but there was an advanced question. That's why I'm just giving you a glimpse, because you should at least know, just know. If that process is time consuming, leave that question in examination. At least you will not be getting minus 1, because you have read, so you know how to leave the time taking questions as well. That's why I'm just discussing. So this is a advanced question. it said 10 to the power minus 6 molar. See, 10 to the power minus 6. Concentration is, sir, but you said when concentration is 10 to the power minus 7, then consider water. For minus 6 also, I'm just giving you an idea. What I have first told you, calculate alpha. So let us calculate alpha. If we will be approximating, let us see the whatever. If I have approximated, let us check that approximation is right. That we were supposed to do. We did that with this question also. So this is a side work which we are doing. So just because we did that side work, so let us do that work over here also. So alpha, okay sir, K is given 1.8 into 10 raised to the power minus 5 upon C is 10 to the power minus 6. You can clearly see if minus 6 goes to numerator, it becomes plus 6 minus 1. That means, sir, it is under root of 18. So this is some absurd value coming, more than 100%. That means whatever you are approximating, with that approximation, things are getting absurd. Because is alpha, what is the maximum value of alpha? 1. With what value you are getting under root of 18 is definitely much larger than 1. So something can dissociate more than 100%. Never. So then why? You have approximated. So whatever approximation you have done for this species is also absurd. That's why absurd value is coming, because nobody can dissociate more than 100%. Whatever I am, I will dissociate only whatever I am. Plus, sir, it is a weak electrolyte. My point is, although it is a weak electrolyte, but you do not know the condition with which it is made. That's why I told you calculate alpha. If it is not getting absurd, coming out less than 5%, do that. If not, do not do that. So we will not do that. Sir, then I am discussing how to do this question, but just for the sake of your understanding, do not attempt it in mains, because it will be time consuming also. Now, just time consuming, not difficult. Whatever I have discussed, I will be doing that only. Okay, sir, but you tell me, if it is a weak acid, because organic acids are weak acid, then if it is a weak acid, why it is dissociating so much? Ostwald dilution law. Even a weak electrolyte can be forced to dissociate completely by increasing volume. Do we know how much volume they have taken to prepare such a solution? No. But they are supplying with molarity, so you have to check using this, that what is its scenario. So sir, its scenario is telling us that no, we have to consider, we cannot do that approximation because its degree of dissociation is much higher. Moving ahead. So it is just behaving like a weak acid as per the value of alpha that we are getting. It is not alpha, it is some absurd value. What should we do? Do the basic thing. Sir, what is the basic thing? I told you. It is now, instead of HA, I am writing this. It will give H plus and A minus. Instead of A minus, the acetate ion, nothing. Its value at equilibrium will be C minus C alpha and C alpha will be produced. What is Ka? K is equal to C alpha square upon 1 minus alpha. We will solve this quadratic. K is given out to be 1.8 into 10 to the power minus 5 is equal to, what is value of C? 10 to the power minus 6 into alpha square upon 1 minus alpha. It will become a quadratic. And when you will solve this quadratic, because it's a traditional question by advance, so when you solve this, I know the value, it will be somewhere around 0.95. You just check this, sir, alpha. After putting on that hard work of quadratic equation, you will get alpha to be, see, 95%. So yes, Ostwald, it must be so much dilute that it is dissociating so much. So if alpha is this, what will be the value of H plus ion from given by this acetic acid? It will be C alpha, that means 0.95 into concentration is given out to be 0.10 to the power minus 6. So scientifically, how much it will become? 9.5 into 10 to the power minus 7. Arey, sir, minus 7. Now, although this acetic acid by dilution must have been made that much of dilute which has increased in alpha, but its concentration is very less. It is still a dilute solution contributing H plus ion, which water contributes. So now you have to again consider H plus ions from water also. Although because of H plus given by acetic acid, the H plus given by water will be less. Sir, less, but some will still dissociate. So what will be the new equilibrium for water? Now, X would be dissociating. Remember which acid? So what will not change? Now value of Kw for water will not change, which is 10 to the power minus 14. So it will be equal to simultaneous equilibrium, X coming from this and this much coming from H plus from acetic acid. Instead of this, I'm just writing C alpha. So what will be concentration of, first I just write this, H plus ion at equilibrium and OH minus ion equilibrium. So 10 is power minus 14 will be equal to how much H plus is given at present at equilibrium by this X by this C alpha. So X plus C alpha. C alpha value you know into OH minus is X. Now again you have to solve quadratic for X. After solving the quadratic for X, add that X with the value of C alpha. Then take minus log, then it will give you pH. So obviously it is not difficult, but it is time consuming. We all know how to solve quadratic, but if quadratic is, there are two quadratics to be solved, it is not meant a question for JEE mains. So, but you should know what to leave and why to leave. So this is what we have done for weak electrolytes. Yes, so moving forward, sometimes instead of mono basic weak acid, polybasic or polyprotic weak acids, as in those acids which are weak but they have an ability to furnish more than one H plus ions. These questions are also sometimes quite famous. In mains also they are asked. That let's say you have a 0.1 molar solution of H2S. Sir, H2S is a weak acid. How do we have to learn? The value of K will also only tell you. We know H2S dissociates in two steps. This I guess you will be knowing. H2S when gives 1H forms bisulfide ion. Bisulfide ion may further furnish H plus and forming the ultimately sulfide ion. Now, look at the value of K. It is 10 to the power minus 7. Much lesser than, so the equilibrium is shifting to forward direction. No sir, if it is less than, if it is 10 to the power minus 3, we say it is not shifting. This is much lesser than minus 3. And one very important thing, whatever be the dissociation constant, the first dissociation constant of a species, the second dissociation constant will be much lesser than the first one. Like in the first dissociation constant is 10 to the power minus 7. The second one is 10 to the power minus 14. This is always in chemistry, we say this very less number of times. This is always true. Sir, why? After giving the first H plus, what has formed? HS minus. HS minus is what? It's a negatively charged species. So minus will attract plus or will furnish more plus. So obviously this minus will have affinity to attract H plus. But instead we are forcing this minus to release this H also in form of H plus. No, it will hugely resist this, and that's why the second and the consecutive dissociations will always be much lesser in magnitude. So you should always remember this. I'm making this a star point because this is very important, that for polyprotic acids, Ka1 is much greater than Ka2, and if it gives 3, so the third one will be, no one will be talking about that. So this you should always keep in mind. Why? Because if I give one first H plus, I become a negative charge species. Now I have affinity toward, I want to eat plus, I want to attract plus. If you want to take one more plus away from me, I will resist that. So this you should keep in. Sir, now what we have to do? Again, that small thing, do in the bracket. This is K, Ka, that means the first dissociation. So what, how do you calculate alpha? Sir, alpha we calculate as, so alpha 1 will be under root of Ka upon, what is its concentration? 10 to the power minus 1. So this is 10 to the power minus 6, so 10 to the power minus 3. Sir, very less. So if first, which is much higher, the first dissociation constant is much higher. If first is this much, second is, sir, negligible. So whatever H plus ion that are coming into the solution, this first dissociation step is only responsible. So why bother? because this H plus ion is anyway not at all contributing. So what is the H plus ion concentration given by this simultaneous? You do not have to take, although I am giving you a basic. C, it is C. So at equilibrium, let's say alpha 1, it's this step's degree of ionization. So this will be C minus C alpha 1. This will be C alpha 1. This will be C alpha 1. But this C alpha 1 is not left alone, because it again, this C alpha 1 is not left alone because it again has to dissociate. So this C alpha 1 was initial for this step. So of this amount, some alpha 2% will be dissociating. So it will be C alpha 1 times of alpha 2. So this much dissociated. So C alpha 1 alpha 2, C alpha 1 alpha 2 formed. But you do not have to do all this. What I've told you in the beginning. What? Because this is negligible, why bother doing such stuff? Because whatever H plus coming from this step is more than sufficient, because first dissociation constant is always much greater than the second one. So what is the approximate H plus ion concentration that you are having with you, sir? Only from this. So what will be H plus ion concentration for you, sir? C alpha 1. Although I have to write plus C alpha 1 alpha 2. C alpha 1 alpha 2. C alpha 1 alpha 2%. This simultaneously we are not taking. Yes, we are theoretically approximating, because mathematically if you will try to add also, it will not contribute to your mathematics. So C alpha 1. What is the value of C? 10 is power minus 1. What is value of alpha 1? Alpha 1 we have recently calculated, yes, over there. 10 is power minus 3. So this is H plus ion concentration. I'm not doing that formula half of pK because I'm directly calculating alpha 1. So multiply that alpha 1 by C. So H plus ion is C alpha 1. Just directly take minus log of this. So pH will be minus of log of 10 raised to power minus 4. It will be directly, no. So your answer is 4. But yes, sometimes in such questions, pH, apart from pH, one thing is also asked. Remember, in chemical equilibrium, if some reactants are negligible, they are close to 0, but you can be asked that negligible value. How to calculate? Again, we will do some common sense. These two reactions, what is asked, let's say if they are asking you, okay, H plus ion contribution is negligible, but I want this negligible amount of sulfide ions. Can you do that? Yes. How? Add these two reactions. Remember chemical equilibrium basic. By adding two reactions, the new reaction that you come up with, equilibrium constant for that new reaction is K1 into K2, multiplication of those two added reactions. So what will be the added reactions are H2S giving us this H minus, HS minus will get cancelled. This will be added up. So it is twice of H plus ion plus this sulfide ion. Let's say its dissociation constant is K, some new equilibrium constant. What will be this? K, sir, K1 into K2, because if you add two reactions, equilibrium constants gets multiplied. In chemical equilibrium, we've done that using it. So do you know the value of K? Yes, sir. 10 raised to power minus 7 and minus 14 is power gets added up. So minus 21. Just check. Yes. Now apply this. I'm changing the color because we have been doing so many things in this question. So calculating here now. Sir, K we know. 10 raised to power minus 21. Now, what is it? Sir, concentration of H plus ion squared into concentration of, okay, sir, this sulfide ion concentration at equilibrium we are interested in. Okay, although this value is negligible, but now we will catch this value upon concentration of H2S. Is H2S dissociating too much? No, sir, it is, alpha is so small, very less. So this C minus C alpha 1 is approximately equal to C only, because the alpha 1 times it is negligible. So whatever weak acid it is taken, it is kept associated only. It has just lost a bit of weight. So what is the concentration of H2S? The concentration that is given, that is 0.1. So this denominator we know. So 10 is power minus 21 becomes, this is nothing but 0.1. 0.1 is directly 10 is power minus 1. What is H plus ion? Sir, pH we have calculated. Sir, you will not take no, because no contribution. H plus ion is contributed by this only. Although this has dissociated negligibly, that negligible amount of H plus also we know. It is pH is 4, value is C alpha. C alpha is 10 to the power minus 4. So this is 10 to the power minus 4 squared. Mathematics you have to keep in mind. 10 to the power minus 4 squared, because H plus ion you got is 10 to the power minus 4. So 10 to the power minus 4 squared becomes minus 8. And that is the negligible value. Let's say that value is y. Calculate that y. So this is how you can calculate the concentration of the negligible. And see, the value is very small. So hence proved. So moving ahead, now you tell me, by just looking at this question, sir, we just did such a question. You will say, sir, sulfide ion concentration, very less people know this common sense, which by the way, which we have already done. Sir, what are you saying we are not getting? See, 0.1 molar H2S is supplied to you. Right, sir? If H2S has a concentration of 0.1 molar, we very well know that it will furnish twice of H plus and sulfide ion. This we know directly. Sir, but K1, K2, we have done that. The overall K of the reaction will be nothing but K1 into K2. So we can definitely calculate this value. Easy to calculate also. 1.4 into 10 to the power minus 14 and minus 7 will become minus 21. Have seen? So the overall K we know, sir. Why you are directly doing overall K? Because you need sulfide ion concentration. Sir, so this is the same question. No, read the word problem. Words problem says 0.1 molar HCl is also added. Sir, it is a strong acid. So when a strong acid will furnish H plus, dissociation of this weak acid when it was alone was very less. We have seen. So in presence of this common ion, H plus will be produced by HCl to a larger extent. What extent? Complete 0.1 will be formed. So its dissociation will be more suppressed. Backward reaction. Sir, how to find? Don't do any of that stoichiometry. Just go by this basic. What doesn't change? This value of K. So value of K you can write as, this value of K can be written as concentration of H plus ion, the squared value, into concentration of sulfide ion, which we are interested in, raised to the power 1 because its coefficient is 1, upon concentration of H2S. Sir, H2S will now be dissociating much lesser. Initially only you have taken its concentration what was given. So still now you will do that. But now the catch is concentration of H plus ion will be from this plus this. Sir, this is very less. So neglect it, because if it is doesn't even matter if I have 1 crore of rupees, if I add 1 rupee or subtract 1 rupee, if I add 10 rupee or subtract 10 rupee, if I add 100 rupee in 1 crore, because it is 10 to the power 7. Minus 7 is in 1 upon 10 to the power 7. So, sir, it will not be contributed. So, again, common ion effect. That theoretical application that you have to approx will kill variables. So, sir, what will be concentration of H plus ion? Sir, it will be just given by this HCl because it's a strong electrolyte. So, I'm just putting down those values. So, K1 and K2 multiplied will give you minus 7 into 10 to the power minus 14. Sir, why not writing 21? It will be cancelled, na? This is 0.1 square. This is okay. Its concentration is 0.1. Good for us. Good for calculation, will be cancelled. And this sulfide ion that we have to calculate, mind you, all these values are at equilibrium. This value we have to calculate. Let's say its value. This value is y. Easy to solve. So this is 0.1, that is 10 to the power minus 1. So minus 1 gone. So over here minus 7 becomes minus 6. Easy. So this value is 1.4 only. This only option has 1.4, although 10 raised power will also come to be. But most of the students, what they do is, sir, over here you just calculated sulfide ion concentration, but here the H plus ion that were produced was by the first step of H2S. But in first step dissociation also, the amount of H plus that it gave, that is C alpha 1, was negligible. The C minus C alpha 1, you still approximated it to be C. So when it was alone, it was not at all dissociating. So in presence of common ion, its dissociation will go to hell. You do not have to worry about it. People fear this, and this is the reason they fear ionic equilibrium, which by going to the basic, you will not. So next, moving forward to this mixture of two weak acids. Actually, practically speaking, for mains per se, you can leave this. But although, I mean, keeping in mind is not that difficult. So the derivation part, okay, you must avoid, but you just can, this is a basic concept only. If HA dissociates, let's say it's a weak acid, it will form its constituent ions. We know that, sir. What will be the dissociation constant? Let's say I'm taking its dissociation constant is K1. Now, if I have another weak acid like we have done for mixture of strong acids, the total overall normality we used to calculate, remember? Now, this is a mixture of two weak acids. So let's say this HB will also furnish H plus and B minus. Sir, if weak acid was alone, it used to dissociate much less. Now in presence of common ion, the dissociation will further be suppressed. We know that, sir. Move ahead. So let's say at time t equal to 0, C1 concentration of this first weak acid I have taken, C1. And let's say alpha 1 is its degree of ionization. So how much it will be dissociated? C minus C1 times of alpha 1 times of C1. This will be formed C1 V1. This will be formed, C1 alpha 1. This will be C1 alpha 1. Now, you will be taking another weak acid also. So its concentration would be, I mean, it may be same, it may be different. So this is C1, C2, they may be same or different. Let's say its degree of ionization is alpha 2. So this will be minus C2 alpha 2. What? Acha, sir, common ion. So that value I will automatically have to write over here because it is simultaneous equilibrium. So this will be furnished from the above. This much will more be created. This is C2 alpha 2. So this will be final concentration of H plus ion as per simultaneous equilibria. What will be B minus concentration? C2 alpha 2. Sir, these ions will be much lesser. What we used to do is we just go to the basic and see to the overall reaction. So just see to the overall reaction. Sir, what is overall concentration of H plus ion? Beta, very easy. How, sir? Because H plus ion concentration at equilibrium is clearly visible. It is via simultaneous equilibrium. C1 alpha 1 plus C2 alpha 2. Done. Sir, but in question the numerical value is supplied of concentration and Ka. Not of alpha 1 and alpha 2. Alpha 1 and alpha 2 you have to calculate. That derivation part, I'm just telling you, all of those out there who feel you want to do that derivation, it is also very easy. Just a few lines of mathematics. I'll just guide you what to do. First you write K1. What will be K1? Concentration of this into this. This concentration you will be taking the simultaneous concentration. This one. So concentration of this into this upon this. What about this? Concentration of this into this upon this will be equal to K2. Because it's a weak electrolyte, weak acid, 1 minus alpha in the denominator, this thing will be 1. So you can clearly see this observation also I'm writing. Okay, let me write this K1 and K2 for you. What will be the value of K1? Let us write. Sir, H plus is C1 alpha 1 plus C2 alpha 2 into this C1 alpha 1 upon C1 common 1 minus alpha 1. What will be K2? Sir, easy na? C1 alpha 1 plus C2 alpha 2 into C2 alpha 2 upon, sir, C2 come out common. This is 1 minus alpha 2. Now this is what I was telling you. because it's a weak electrolyte, this 1 minus will be approximately 1, this will be approximately 1, so gone. This C2 will be cancelled by this C1 will be cancelled by this. So can you tell me what is ratio of, I'm doing it independently because you should at least know these results. Not very famous for mains, so those who are finding it difficult can leave this also. So what is ratio of K1 upon K2? Sir, this is also gone. So this is simply alpha 1 upon alpha 2, sir. Yes. Replace alpha 1 or alpha 2 in any of the equation. You will just get an equation. Let's say if I have replaced alpha 1, I'll get an equation in form of alpha 2. Calculate alpha 2. Then calculate alpha 1. So you will be getting value of alpha 1 and alpha 2. I am giving you the result. I am just not giving that basic derivation because all of those who are aiming for advanced can do this. If you find it difficult, just give a comment in the comment section. I'll come back to it in some other session. So what will be H plus ion concentration at equilibrium, which we have to remember, sir? It is easy. It is under root of Ka1C1, K1 as in of this. So I have written as K1. So let me write as K1 of the K1C1 plus K2C2, where K1 is dissociation constant of first weak acid, K2 is dissociation of second weak acid. This is not successive value. So this is Ka1 and this is Ka of this. Of first acid is K1 and of second acid is, they are not successive values. Remember, for a polyprotic acid, K1, K2 are successive values. So do not get confused by that. So dissociation constant of first acid into C1 plus dissociation constant of second acid into C2. Easy. Now, this formula also you can apply only when the H plus ion concentration will come out to be larger than 10 raised power minus 6. If this value goes below 10 raised power minus 7, then again water you have to take. So for that what we'll do? Simply add Kw over here. So if this concentration goes below 10 raised power minus 7 and or even equal to 10 raised power 7, add Kw also in the under root, because that will be the contribution of H plus ions given by water. So these are all, good things, but I am suggesting if you are finding it difficult, you can leave for mains examination. So finally, this has brought us to the end of pH calculation discussion and start of salt hydrolysis, the another topic, very formula based, asked in paper. So what is salt hydrolysis? From 10th class, you know this basic. What? That acid and base react with each other and the reaction is known as neutralization. We know this, sir. And forms what? They forms salt and water. And recently, through equilibrium, you know, sir, no reaction proceeds forward 100%. They reach a point of equilibrium. That means backward reaction also takes place. So when this backward reaction takes place, actually this backward reaction is known as salt hydrolysis. So we very well know, if we do not know, then at least know this. What are the possibilities of having these types of acid and base? Can be either strong or weak, a strong electrolyte or a weak electrolyte. So for example, the first case, if I have a strong acid and a strong base, I'm directly using an example. Mineral acids are strong acids, metallic hydroxides are strong bases. So if I have a strong acid and strong base, they will definitely form a salt, which is a neutral salt, along with the formation of water. So if I have acid and base, they will react and form salt and water. Okay. What salt it is, sir? Sir, it's a neutral salt. So do you know, because it's a neutral salt, so where the equilibrium will rise? Sir, what are you talking? Strong acid will completely dissociate and form H plus. Strong base will completely dissociate and form OH minus. These H plus and OH minus and love each other because we know water is not an electrolyte and form water. Sir, why the equilibrium will go backward? Although from now we know equilibrium reaches not 100%. Let's say its K will be 10, very, very, very large. So almost 99.99% of the, but some will be remaining. So my point is, because it's a neutral salt that we know theoretically, and now we just know H plus OH minus and love each other and forms water. So in such cases, backward reaction negligibly takes place. Hence, we conclude with the statement that hydrolysis is not happening over here. So there is no hydrolysis. So this first case, which is the case of salt of strong acid and strong base, they do not undergo hydrolysis. So if you add salt in water, a salt of strong acid, strong base, what will be its pH? pH of water. So pH of such salts is decided by water, that is pH is 7 at 25 degrees Celsius. Now, if we have permutation combinations of these, example, one is strong and one is weak. So let us discuss that. So that will be actually the first case of salt hydrolysis. So I am taking here, let's say I have taken HCl, sir, it's a strong acid. Okay, very good. And I am taking NH4OH. So what will be the salt? Sir, NH4Cl. But here we are discussing salt hydrolysis. So I am writing the reverse reaction as in NH4Cl when interacts with water forms, this is salt hydrolysis, forms NH4OH and HCl. We know this reaction is neutralization. We have just seen. But here hydrolysis will take place. So what is hydrolysis? Interaction with water. How can you say that, sir? This is a molecular equation because we are studying ionic equilibrium. So let us write ionic equation for this. So can you tell me how can I write ionic equation? Sir, ions are formed by electrolytes and we know the quality of electrolytes. They may be strong, they may be weak. So let us write that ionic equation on the basis of how much ions they are furnishing. Okay, let us write, sir. So you tell me NH4Cl, because it's a salt, it will completely dissociate. It will completely dissociate and forms NH4 plus and Cl minus ion, right? Yes, sir. Salt is until unless specified. I have not specified sparingly soluble salt till now. We'll go to sparingly soluble salt topic, but in general, salt of any component, either whatever part is weak, if I'm salt has a property because it's an ionic compound produces ions. So salt is generally a strong electrolyte. Water, sir, we know it is not at all an electrolyte. Yes, its dissociation is considered, but it is like a very poor person. When it go water, the H plus and OH minus ion it gives is negligible. So when a person who is poor goes to a big town, he does not say, I have 10 rupees. When he is in hometown, that he will go to a chai stall and then he'll pay 5 rupees out of that 10 rupees. As in, you can only consider the dissociation of such weak electrolytes when they are alone. In presence of these big people, their ionization is neglected. So hence writing as a molecule. Similarly over there, you tell me NH4OH, sir, it is a weak base. You should remember this. So weak base, can I write this weak base as it is dissociating? No, sir. In terms of strong electrolytes, I will not consider its dissociation. This will be completely dissociating, sir, because it's a strong acid. So I am talking of salt of what? So this becomes a salt of strong acid and a weak base. Now you tell me anything is getting cancelled? Yes, sir. So what ions you see? Sir, cation. So this becomes cationic hydrolysis. So this becomes cationic hydrolysis. It is producing what? Sir, it is producing, with common sense also you can say, if salt is of strong acid weak base, strong acid will definitely make the will make the solution acidic. So somebody call it acidic hydrolysis, somebody call it cationic hydrolysis. So now what are we doing after learning this, sir? Calculate pH. Again, the point is saying we have to calculate pH, but they are now pH calculation of salts. How will we do that, sir? Again, very easy. How? Sir, let us say question has supplied with you the constant. Obviously, salt hydrolysis taking place, question supplies you with the concentration of salt. Sir, if one molecule of salt breaks, 1 and 1 are formed. So at time t equal to 0, what is the concentration of these ions, sir? C and C. Product initially not formed. Then what? Sir, this ion is gone. Then why you are writing it? So let me be precise with my reaction. So I have NH4 plus and water giving me NH4OH along with H plus ions. At time t equal to 0, I had this C. Nothing was formed initially. At equilibrium, I'm saying, let us say, what is the degree of dissociation? Over here, it is getting hydrolyzed. So the nomenclature, the English language says degree of hydrolysis. And to that degree of, it is just like degree of dissociation alpha, but nomenclature says degree of hydrolysis, and NCERT represent it as small h. So let h% is its degree of hydrolysis. So H times of C is gone. So how much is left? C minus CH. Water not playing any role, just a solvent. This CH is formed and CH is formed. Can you write dissociation constant? Sir, this is not dissociation. This is hydrolysis constant. So to hydrolysis constant, I'm writing KH. This is what? This is hydrolysis constant of the salt. So can you tell me what this hydrolysis constant can be written as? Yes, sir. Tell me then. Concentration of NH4OH, which is CH. Concentration of H plus ion, which is again CH. So it becomes C square H square upon, this is C comes out to be common. So 1 minus H, I'm cancelling 1 square from the numerator. This is gone because C coming out to be common. Now, sir, can we do that thing over here also? Yes. What? Here H is very less than 1. Therefore, 1 minus H is approximately equal to 1. Why, sir? Now let us get that logic. That is important. Sir, if this NH4OH, you just see this reaction as neutralization only. Suppose you have 100 molecules of HCl. 100 H plus will be given because it's a strong electrolyte. NH4OH is a weak base, agreed. Let's say it is dissociating 5%. So out of those 100 molecules of NH4OH, how much OH minus ion will be given? 5. But as soon as those 5 H plus sees those H plus ions, H plus and OH minus ion will form water. And this equilibrium will feel my OH minus ion is gone. So according to Le-Chatelier's principle, it will start dissociating more and more. So whenever a strong counterpart is present, weak counterpart has to dissociate completely. Therefore, this reaction will also undergo neutralization completely, because this strong electrolyte will force this weak electrolyte to completely dissociate. You got that point? I just explain it again because students miss it. I just explain that thing over here again. See, what am I saying is NH4OH is a weak electrolyte. Understood. Agreed. If 100 molecules are taken, then at equilibrium, only 5 are broken. So 95 are here. Only 5 and 5 needs to be furnished. NH4OH wants to furnish only 5 OH minus, and that's it. So you tell me what will be the value. K does not depend upon these concentration, but these concentration at equilibrium, that ratio becomes K. So what K wants? 5 upon 95. Now, if I have a strong electrolyte, it will completely dissociate and form these ions. So this is 0 approximately, and 100 of these people are present. So initially first this out of this 100, 5 H plus will come and will go to OH minus. Oh, OH minus, how are you? And what these H plus will do with those OH minus ion, they'll form water. This equilibrium will feel my 5 OH minus ion are gone. Le-Chatelet's principle, product decreased. So if you remove product, what this equilibrium will do? It will say, array, oppose. How will they oppose? They will create more. So further 5, after that further 5, because they are present in equal amount, 100. You got that point? So what I'm saying is, whenever a strong electrolyte is present, weak electrolyte does not want to dissociate. But this strong electrolyte forces this weak electrolyte to dissociate completely. Therefore, if their neutralization is happening, so the reverse hydrolysis will not be happening. Some people learn it. Or 1 minus. This is the logic behind it. I hope you got that point. Now, sir, if 1 minus H is 1, then I can directly say, what is KH? KH is nothing but CH square. So what does H become? H become under root of KH upon C. Now, if H is under root of KH upon C, can you tell me what is concentration of H plus ions, sir? CH. Just like C alpha for acids. Moving ahead. So therefore, H plus ion concentration at equilibrium is nothing but CH, and value of H we recently calculated. So this will be equal to C into under root of KH upon C. C coming on the root, so becomes KH into C. Sir, we see the formula. But KH is not given in the question. What is given? Sir, experimentally we know the dissociation constants. Sir, acid is weak, acid is strong. We have taken strong acid. Completely, its K value is not defined. It is very large, so not given because it completely dissociates. But in these questions, KB will be given. So KB given, sir, KH not given. So you have to, this is my question 1. So you have to think of something which will give you a relationship between KH and KB. So can you tell me how do you write? So I can say for the base, which is NH4OH, its dissociation is NH4 plus and OH minus, and its dissociation is governed by its dissociation constant KB, which is equal to NH4 plus into OH minus, that is concentration of product upon reactant. This we very well know. Okay, sir. Why you are telling us this? Because you also know for water, which is also not dissociating in when these strong electrolytes are present, I am therefore independently writing their equilibrium, because in front of those strong electrolytes, they will be shy. But independently, you can see what they are doing. So this Kw will be equal to H plus into OH minus ion. Can you tell me by seeing the value of Kw? Okay, so KH. Okay, KH we have directly placed the units. So let us write KH again. Concentration of base into H plus. So also for KH, what you can write? Concentration of base into H plus. Concentration of base into H plus. These are the product for the hydrolysis reaction. And the reactants are the cation and water. And the reactants are the cation and water. Now, can you find a relationship between KB, KW and KH? Yes. Just check. KH is nothing but KW upon KB. As in, you multiply KB and KH, you will get KW. KB is this, KH is this, multiply them. Ammonium ion gone. NH4OH, NH4H gone. What are you left with? H plus OH minus ion. Water concentration is not even considered. So it will go, so it will become Kw. This is also a very important relationship. I do not want you to learn this derivation, but this is the first important conclusion that you should remember. Hydrolysis constant will be equal to Kw upon whatever weaker part is there. If base is weak, Kb. If acid will be weak, Ka. Hello. Moving ahead. Sir, if we know this value of Kh, so we can put over here. That is what we have to do. So therefore, what will be concentration of H plus ion at equilibrium? Sir, under root of C into Kh, which we recently calculated. It is Kw upon Kb. All these values are known, sir. So this is your another box which you should remember. But just for mains, I am telling you, you design it in form of log, in form of pH. So take minus log. So minus of log of H plus ion concentration becomes half, will come out to be as 1 by 2. So inside what you will have, minus of log of Kw minus of log of C. This will come out to be in the, because log of A into B is log A plus log B, and log of A upon B is log A minus log B. And because we are taking minus log, so that minus becomes plus. So this is log of Kb. So, or I can simply say pH is equal to, this is pKw. What is pKw at 25 degrees Celsius? 14. 14 by 2 is 7, sir. I am giving you a trick also to remember this formula. What type of salt you have used? Strong acid. So acid is strong, so pH will be less than 7. Just see. 7 minus half of. Minus you have taken out to be common. So this will become minus of log of Kb. If going inside, minus of log of Kb can be written as pKb. And because you have taken minus to be constant, so this minus will become plus. This is the formula I am seriously asking you to please keep in your mind, because it will give you marks directly. Very important. Again, what is pH of a salt of strong acid but a weak base? Sir, strong acid, so pH will be less than 7. So 7 minus, but what should be subtracted? Half of pK of the weaker counterpart, which is base in this case, plus log C. What is C? C is the concentration of salt. What else conclusion you should remember? KH is equal to Kw upon Kb, and this overall formula also. Again, mains question will be done with this. Just for the sake of those people who are just anxious, how advanced plays with it. The value of this dissociation, this hydrolysis constant H, where it is this here. We have approximated this, na? Just like in case of those acids, weak acids, what we have done. If we find this value H to be less than 5%, 0.05, you're good. Practically, if it is 0.1 also, it will be good. But if it is more than 0.1, then this approximation is not valid. This is point number 1. And point number 2 is, if this is the first part where JEE plays, advance. Next point is this H plus ion concentration comes out to be more than 10 raised to minus 6, good. But 10 raised to minus 7 and lower, that is minus 8 minus. Now water will also come into picture, and say I'll also give H plus. So over there you have to again calculate common ion of H plus ion given by water. But those are advanced. I'm just iterating it. Those who feel you want to know more about it, but that will be advanced. So first you just finish off with this mains, then we all have advanced journey on our hands. Moving ahead. So this finishes the topic of salt hydrolysis of strong acid and weak base. Yes, so now just in order to save some of our time, I am repeating the same thing as we have done in salt of strong acid, weak base. Now I am taking salt of weak acid and a strong base. Weak acid is acetic acid, organic acids are weak. Strong base is a metal hydroxide. This is neutralization, but reverse will be hydrolysis. Now we have to check whether any ion of the salt is interacting with water. If interacting, it is undergoing hydrolysis. So Writing ionic form, salt is always a strong electrolyte, forming ions. Water, no, associated. Weak acid, associated. NaOH will form the ions. Sodium get cancelled, so who are remaining? The anions. Hence, such hydrolysis is called anionic hydrolysis. Now, removing the cancelled part, writing the fresh reaction like this. Because let's say C is the concentration of salt taken, so this at time t equal to 0, concentration of these anions will be C. Initially nothing happened. Let's H is its degree of hydrolysis, so C minus, the similar way, CH and CH. Here I have written the value of KH, concentration of product upon reactant. Again, here I have written the dissociation constant of weak acid. Now again observe Ka into KH. CH3COOH, numerator, denominator, cancelled. CH3COO minus, CH3COO minus cancelled. What are you left with? OH minus and H plus, which is equal to Kw. So that result again, what result? Like just in the previous case, over here also, I can say KH is nothing but Kw upon the dissociation constant of the weaker part. Just like in this case. Here base was weak, so it is KH upon KB, Kw upon KB. Over here it is Kw upon Ka. Everything is just the same. Again, if you will put the value, so this will be CH square upon 1 minus H. Again, this is because backward reaction will take place drastically. So this is happening very small. So H is less than 1. Again, this thing. So again, what you have KH as CH square. So H will be under root of KH into C. So again, now whatever H plus ion concentration you had in form of CH, whatever H plus ion concentration you had in form of CH, making it to be under root of KH upon C, that was H plus ion concentration, just like what we have done with bases. So over here, instead of H plus ion concentration, we will be getting OH minus ion concentration. So OH minus ion concentration will be under root of KH into C. Putting the value of KH, so it will be KH is Kw upon the weaker part, which is Ka into C. Easy. This also I suggest, like in that case, H plus was coming out to be Kw upon Kb into C. Here it is Kw upon K into C. Or the other form is taking log minus log. So this will become POH and this is minus of, okay, 1 by 2 will definitely come first. So half, what is left behind? Minus of log of Kw minus of log of C minus plus log of Pk plus log of Ka. Now, so this POH will be equal to, this is 14 by 2 is 7 plus half of, I'm taking half plus only because I'm writing it as log of Ka minus log of C. But this is POH, sir. What are you interested in, my friends? Sir, we are interested in pH. So write pH. What will be pH? Sir, pH will be equal to 14 minus POH. POH is this, so 14 minus POH is 14 minus, complete this thing. 14 minus 7 will become 7. So pH will be equal to 7. This plus will become minus. A half will come in the outside as common. So I've taken this minus. So minus, if I've taken over here, this will be remaining as it is because minus I've furnished in the outside of the bracket. So this is just as it is. So what it will be, if it is log of Ka, so it will be minus pKa. It will be minus pKa. And this is again minus log C. Taking this minus outside, so pH will be equal to 7 plus half of pKa plus log C. Now I am coming to a conclusion. This is what where I'm making the box, where this is what I want you to learn. Why? Sir, because it has got symmetry. Previous case was Strong acid, weak base. Strong acid as in pH will be less than 7. So 7 minus. What was getting subtracted? Half of pK of whatever weaker counterpart you have plus log C. Here also. Half of pK of what weaker counterpart is acid over here plus log C. And 7 plus, why? Because strong base. So it will make solution basic, so pH will be more than 7. So instead of this derivations, then sir, why you have done this derivation? At least you can have a look at it so that the learning the formula will become a piece of cake for you. At least when you get a bigger damage in your skin, whatever disease or whatever problems you had which gives you less of pain becomes easy. So a bigger pain makes such a pain, learning this outcome, easier. So moving forward. Yes, so now let's just gear up for this last case of salt hydrolysis, salt of weak acid and weak base. A very famous weak acid, weak base salt is ammonium acetate. Ammonium acetate, when goes to water, form acetic acid, ammonium hydroxide. This is just the same, so I've just did this for you to be precise and quick. Then writing the ionic form of it, sir, you said salt is always a strong electrolyte, will completely dissociate, perfect, form the corresponding cations and anions. But this acid and base, sir, they both are weak. So they will not be forming ions, sir, because this is an electrolyte. Again, I have written the value, the hydrolysis constant KH for you. I have written those Ka, Kb values and dissociation constant of water so that you may relate also. What was the value of hydrolysis constant in terms of dissociation constant of weak counterpart? So Kw upon K of the weaker part. Here both the parts are weak. So it will be equal to Kw upon dissociation constants of both the weaker parts multiplied. You can definitely see if you take Kw divided by Kb values, they are there, you will get this. So this I have presented just to make you quick and understand that this is the relationship with the same symmetry. Moving ahead, let's say if H is the degree of hydrolysis in this case, so H percentage will dissociate. How much is left? C minus CH. I'm sorry. So how much is left? Sir, C minus CH. This is also C minus CH. How much that will be produced? Sir, CH. This one, CH. So let us just substitute this value. Concentration of acid and base. This is C square H square upon, sir, C minus CH double C minus CH the whole square. Simplify, C square coming out. So you'll be getting H square upon 1 minus H the whole square. This is equal to Kw. Now, this is different. Why? Over there, we were confidently saying that sir, hydrolysis is happening at a very slow pace. So H was very less than 1. We cannot be that sure. Almost. Actually, this H is lesser than 1. But we cannot be sure of that because it depends upon both the dissociation constants of acids and bases. So, and that practicality also, the strong counterpart was forcing the weaker one to be going in the neutralization side. Over here, nobody will force. But yes, the forcing ability may change as per their value of K and Kb. That's why I'm being not generalizing it. That this will, I will not write over here that this 1 minus H is definitely lesser than 1. I'm not commenting. This is the general that you have to follow. So what you're getting out of it, sir? This is equal to KH. So therefore, H upon 1 minus H becomes under root of KH. This is a relationship which I will want you to just keep in your mind. Not used much, it means, but this is what you should keep in mind. Okay, sir, we got this. Sir, but we have to calculate pH. How to? Nobody is giving H plus, nobody is giving OH minus. Just check in the solution. Somebody is giving H plus. It doesn't matter. What is the content? This is the H plus ion. So, if you want the concentration of H plus ion, we can use this value Ka. What is this? Sir, H plus ion will be equal to, so I'm using it. So, therefore, in order to calculate, I'm using that expression where equilibrium H plus ion is equal to what? K into acid upon the ion. Ka into acid upon the ion. Sir, this is the expression. These are all equilibrium concentrations. Mind you, I have not written equilibrium, but from at least till now after chemical and ionic, you know these values are equilibrium concentrations. Okay, sir. So this H plus is this we have written over there. Sir, but how, what shall we do about this ratio? Acid upon its ion ratio. Just look at over here. Can you say concentration of both acid and base at equilibrium are equal, both are CH? Yes, sir. Can you say concentration of both this negative ion and this positive ion of the salt are also equal? So don't you see them in equation of KH? How? Sir, if this concentration acid and base is equal, can I replace this base by acid only? Yes. So what I'm saying is, if I rewrite the equation as, or I can also say KH is equal to acetic acid, which is the weak acid. Now, instead of writing this base again, because its concentration is also equal to acid's concentration, so acid concentration can be squared because both are equal. Mathematically, I'm saying. Similarly, if I say this acetate ion concentration is equal to ammonium ion, so if I replace this ammonium ion, because I can replace both concentrations are same, so both are equal. So if I'm in place of ammonium ion, I'm writing acetate ion, so acetate ion will also be squared. Hello. Okay. Now, sir, this value is there also. This is acid upon ion, which is under root of KH. So from here, using this, I can say H plus ion concentration is nothing but it is equal to Ka into under root of this KH. And KH, we have already seen, is equal to K into Kb. Remember this one? Just like that. So this is the only catch, the difference. So H plus ion concentration will be under root of Kw into this K, when comes inside becomes squared, denominator gone, so Ka upon Kb. Now this is a relation I want you to remember. Instead of that, a better version, take minus log. So minus log of H plus will give you pH equals to, this half will come as property of log. Minus of log of Kw is, sir, pKw. Plus minus of log of Ka is, sir, pKa. And this is in the denominator, so it will be with a negative sign. So that will be equal to minus of pKb. But this half is multiplied to all of them. Or generalizing, keeping, making it into that format, 7 plus or 7 minus. So this is again 7 with a plus sign, half of pKa minus pKb. Now this is the result I am much interested in. So come again. For weak acids, pH was 7 minus. Salt of, one is weak, other is strong. Weak acid, strong base. Weak acid, strong base, salt, strong base, so 7 plus. Opposite, strong acid, weak base, 7 minus. Over there, the factor was half of pK of the weaker part plus log C, the concentration. Here, concentration of salt is gone. So one important conclusion, for weak acid, weak base salt, concentration does not play any part in calculation of pH. First point. Second point, here This is 7 plus half of pK minus pKb. It can be more than 7, less than 7, depending upon the value of pKa and pKb. So you cannot generalize whether it will be acidic or basic, depends upon the value of K and Kb. Now, last thing, can this value be equal to a neutral solution? Can, like, salt of strong acid, strong base do not hydrolyze. Its pH is pH of water. Can it also have a value of 7? Yes, when both these values are equal. And you know what? This is a very famous conclusion. Ka and Kb of both acetic acid and of ammonium hydroxide are both equal. But this is not for all. This is for acetic acid and ammonium hydroxide. You should just keep this in mind. So for salt of ammonium acetate, the pH will definitely be 7. It's an extra fact. You may learn it, you may skip it, but this is a conclusion. So moving forward, let us see through some examples so that we may feel comfortable. Sir, so much of theory we have seen, at least give some examples. So these are all the questions that have come. I mean, there are more, I've just taken few. If pK of lactic acid, sir, what is lactic acid? Even they gave you, this is lactic acid. I mean, it's an organic, it's an organic acid. So generally you can assume it to be RCOH, whatever the structure of R may be. It's a weak acid because an organic acid. So the pK value is given to be 5. This is 5. Then you have to calculate the pH of this much molar calcium lactate solution. Sir, calcium lactate, what it will be? See, we know calcium lactate is, calcium is the cation, and what will be the anion of carboxylate ion? RCOO minus. So RCOO, but calcium has a valency of 2. So you just tell me, if I have, let's say M is my concentration, molarity of the salt. Like when we used to write the ionic form of equation, how will you write its ionic form, sir? Calcium plus 2 and twice of RCOO minus. You got that point? So if molarity of the salt was M, then of the anion, because it is a salt, calcium lactate is a salt of metal hydroxide is a strong base. So it's a strong base and a weak acid. So you should keep this thing in mind, that because it's a salt of a strong base and a weak acid, so it will give a base, it's a basic salt. So pH will be equal to 7 plus, remember? Then half of pK of the weaker part, which is acid in this case, plus log C. Now this C is the concentration. But the concentration of what? Because over here, anions are left behind. So it's an anionic hydrolysis, remember? Now some people say, sir, these are 2. Doesn't matter if it is 2. When these ions are free, they will interact with water. This is the hydrolysis. Can you write that reaction? Yes, sir. RCOO minus interacts with water. This is called hydrolysis. Will form RCOOH and will form OH minus ion. So rest everything is same. So the formula will also come out to be same. Just the concentration, it will not be the concentration given. Because if you take 1 mole of salt, twice of the anions are given. So concentration will not be this much, but it will be equal to twice of this. So what is 0.005 into 2 is, sir, it is 0.01. That is 10 raised power minus 2. That's it. You just can see through the value while reading the question, but with practice it will come, and put the value over here. So let's put the value over there. So after seeing this, you can definitely tell me what will be the value we are calculating. So help me calculate it. So pH will be equal to, sir, 7 plus half of, what is pK, sir? See, directly given, 5, plus what is the concentration, the overall concentration of the ion you needed. Go to that derivation. I've told you all the derivation does not has to be done, but you can just check that the concentration it's not C, it's twice of C, because 1 mole will give twice of, that's it. So it will be 10 raised to the power minus 2. Solve it. 7 plus half of this is 5 minus 2 is 3. So 3 by 2 becomes 1.5. So this becomes 8.5. But we have to write in this. So 8.5 becomes 85 into 10 raised to the power minus 1. Answer is 85. So these are some simple questions, but you should have the confidence. Another question, I guess I'll just tell you. This is a weak base. Okay, sir. This is a strong acid. Okay, sir. It's a salt of strong acid and a weak base. How much salt is formed? First, you have to just check what will be the number of millimoles, because we need to know the stoichiometry. This much of base is reacting with this much of acid. We know salt will be formed, and the formed salt in solution will undergo hydrolysis. So it is a case of salt hydrolysis. But how much salt is formed, the concentration we need to know. So why millimoles you are saying, sir? Because volume is given in ml. So can you tell me the millimoles first of acid? Yes, sir. What is number of moles? Why I am saying? Because volume you can take in ml only. Do not convert. So volume into molarity is number of moles. So 40 into 5. 4 5 are 20, 0, 400, 2 decimals. So this is 2 millimoles. Can you tell me what is millimoles of base? How am I calculating molarity into volume? That's it. So 20, this is directly 2. So sir, both are 2, 2. So how much salt will be formed? Acid is 2, base is 2. How much salt will be formed? 2. So the formed salt, which is NH4Cl, will have 2 moles. But we have to put the concentration. So what will be its concentration, sir? Moles are 2 millimoles. But what is the volume of solution now? 20 ml of this is mixed with 40 ml. So this is not ionic equilibrium. This is mole concept. 40 ml of this is mixed with 20 ml of this. So total volume of solution becomes 60 ml. Milli cancelled. That's why it said use millimoles only. So the concentration will be 1 by 30. Now it is just maths. But mathematics also you will apply for what? Sir, mathematics will apply for salt of strong acid and weak base. So what will be the value of pH? Strong acids are so 7 minus. Remember, strong acid 7 minus half of pK of the weaker part. Who is weak? Base. So pKb must be given in the question plus log of C. This C we have just calculated 1 by 30. Do the property. Log A upon B is log A minus log B. Log 1 is 0. Log B will be log 30. 30 can be written as 10 into 3. Log 10 is 1. Log 3 is 0.48, 0.5. Options are there, so you can solve. Just try and attempt the question. So I'll move forward. So just moving forward with this one more example, although you will be getting many questions of these salt hydrolysis, but one more example. pH of ammonium phosphate is given. The reason I'm speaking about this example is phosphate, although is a PO4 3 minus ion, but those polyprotic, I mean those ions which have more than one charges, the polyprotic acids, the amphiprotic acid the species, those I have left because they are only meant for good advanced questions. So not even asked. For example, even if it is asked, you have to just go by your basic. You will just say, sir, it's ammonium cation, so it's an A plus cation and it's a B minus ion for you. Although it has 3 minus charge, it will interact with water with one step only. So what I'm saying is, what you know is just the same basic. What do you know? Sir, it's a ammonium hydroxide is a weak base. Okay, so it's a salt of weak base. Sir, phosphate, the phosphate is H3PO4, but H3PO4 will be first dissociating to give H plus followed by H2PO4 minus. This is the first dissociation constant, which is much higher. So K1 of this acid is larger, but when this will dissociate, it will be K2, giving H plus and HPO4 2 minus. And when this will dissociate in the third step, forming PO4 3 minus. Sir, that is also a weak acid because for HPO4 2 minus, it will dissociate to form H plus and PO4 3 minus. So this K3 will be much lesser. So it is also a weak acid is what I'm telling you. This we have already discussed when I said dissociation constant of first is always much greater than the second one. So even if we have left, because I'm telling you, amphiprotic ions, the polyprotic ion dissociation, although in case of H2S also the common sense I have given. So the mains question and more or less the advanced one also will be done. Few things I have left, but that should be left. This is the segregation which I'm attempting to do with all of you. So moving ahead. So sir, that means this acid is also weak acid. So this is a salt of weak base and a weak acid. So if such a salt, let's say I'm giving you its formula, ammonium whole thrice PO4. This is your salt. So if such a salt is dissociating, sir, but now the number of ions will be furnished by it will be different. It's a salt of weak acid and weak base. Remember what is its formula? The pH was equal to 7 plus half of pKa minus pKb. It was independent of the concentration, so no worries. Just put the values. The values are given, so you just put these values and move forward. So moving ahead. Now, coming to the next and the most important, one of the most salt hydrolysis is also important. Coming to the next topic, we have buffer solution. Now, what is a buffer solution? Our stomach. You eat anything from outside, although you feel little uncomfortable the night at which you ate those substances, but in the morning when you wake up, your body automatically adjusts itself. No matter you drink cold drinks and whatever basic stuffs. So your stomach is the best example of a buffer solution, which shows you can have any amount of acid, strong acid, any amount of strong base. When it goes to your stomach, your blood acts as a buffer solution and normalizes that added strong acid and strong base until and unless the added amount is not high enough. This does not mean you inject a drug from outside and say my blood is a buffer solution. If the quantity of acid or base that you are injecting is limited, it's not high, that's a buffer solution. So basically, what's a buffer solution? Which resists the change in its pH. Now, there are three types of buffer, but for mains essentially per se, we have two types of buffer: acidic buffer and basic buffer. Now, what is an acidic buffer? It's a mixture of what? Of weak acid and its salt with a strong base. What's a basic buffer? It's also a mixture of what? Of weak base and the salt of that weak base with a strong acid. Now, giving you an example of what? Of buffer action. You should understand this because JEE has asked, mains have also started framing questions around them. So let us understand, sir, how they resist change in pH. We'll see. Let us talk of acidic buffer first. So you have an acidic buffer. Okay, sir. Acidic buffer is what? Weak acid and its salt with a strong base. So this is your weak acid. Let's say I have, okay, I use first, let's say I have 100 molecules of them and 100 molecules of them initially at T equal to 0. Now, we know salt is what type of electrolyte? Strong electrolyte, completely dissociated. So when equilibrium between them is reached, it will be completely dissociated. 100 of acetate ion will be formed and 100 of Na plus ions will be formed. Now, this is a weak acid. If it would have been existing alone, then also it would be dissociating some 5 rupees, 5%, less, maybe less than 5. Because of the presence of this common ion, how much of amount of this common ion? The equal amount as if its acid was present. So because of common ion effect, its dissociation will be further suppressed. So let's say, but still some of it will be dissociating. So let's say at equilibrium, 99 of acetic acid is still remaining, 1 is produced from this side because dissociation suppressed due to common ion. Now, sir, how can you say it can resist change in pH? I'll show you. Let's say I'm adding externally HCl, strong acid. But the amount of acid that I'm injecting is much lesser than the amount which is already present. That is, what you eat, you should not put an injection of acid. You just eat cold drink cold drink. That can be managed. So let's say if I'm adding 10 HCl, so 10 H plus will be introduced. Sorry, if H plus will be introduced, pH will change. No. Why? I'll tell you. As soon as this 10 H plus extra H plus ion, the green colored H plus ions are coming, how many of them have came? 10. Now plus is attracted by what? Minus. It will go to, so minuses are same. How many minus are present? Acetic acid has furnished too many acetate ions. 100 acetate ions are present. So as soon as H plus enters, these excess of acetate ions meet with them, and what is formed? Sir, acetic acid. What type of electrolyte it is? Weak. So it will remain in the backward direction. But you will say, sir, acetic, okay, 10 H plus have extra came, 10 CH3COO minus mixed with them and form CH3COOH, because we know it's a weak acid. For example, let's say it's a weak acid, that means its degree of dissociation will be very less. Its K will be of the order of 10 raised to the power minus 3. Let's say its K value is 10 raised to the power minus 5. So if for this reaction coming forward has a dissociation constant of 10 raised to the power minus 5, so going back, if you reverse the reaction, K will be reciprocal. 1 upon 10 raised to the power minus 5 is 10 raised to the power plus 5. So their addition, their attraction towards each other has a kinetic velocity of 10 raised to the power 5. So all these H plus are consumed by this CH3COO minus, and what is formed? Acid. Similarly, if I introduce extra base, let's say I am introducing strong base, NaOH, completely, it will be introducing 10 OH minus ions. So will these OH minus ions standing in the solution? No, they'll also be gone. From where? Minus will be attracted by plus. If O minus goes to Na plus home, Na plus will say, no, I don't like you, because Na plus and OH minus completely dissociates. So Na plus OH minus ion are completely apart from each other. They will not attract, but there is presence of H plus. This H plus will attach with OH minus and forms water. Water is not a electrolyte. It will be formed. But sir, 10 OH minus ion you have added. You have only 1 H plus. Now, the moment out of that 1 H plus, it is gone to this equilibrium, although its dissociation is suppressed, but it wants at least 1 to this equilibrium. What it will feel? Sir, my H plus is gone. So if product is removed, Le Chatelier's principle will shift this equilibrium to forward direction. And also you have 99 molecules of this acid still remaining. So they will at least want, in order, whenever you remove 1 H plus, their Q will be disturbed, because you are removing product, equilibrium will shift forward direction. So 99 of them are still there. So 1 more will be dissociated. That again 1 extra H plus will be carried by this OH minus ion. 1 more will be dissociating. So until and unless these extra OH minus ion are killed, it will keep on dissociating. I told you, a strong electrolyte can force a weak electrolyte to dissociate. So this is how addition of extra H plus and extra OH minus ion is not creating any pH change, any significant pH change, because they are consumed, and this is called buffer action. Over here also you can say that if I'm adding extra OH minus ion, let's say I'm adding, okay, over here also this is a weak base, so 99 of it will be remaining, 1 will be produced, because common ion, ammonium ion, it will be 100 and 100. The moment you are introducing OH minus ion will do what? They will be attracted by OH minus ion will be attracted by the positive ions, which is NH4 plus, and will be forming NH4OH. Weak base will be formed. Because its dissociation is much lesser, so its association will be much larger. So all these OH minus ion added will be forced to form NH4OH, OH minus ion not left. Now again, if added H plus from outside, this H plus will be attracted by OH minus ion, and what will be formed? Water. Again, this base will be start dissociating till creating OH minus ion that are sufficient for these extra H plus ions, and the added H plus and OH minus ion, I'm again saying, a buffer solution is a solution which resists pH change when you add strong acid and strong base, but added acid and strong base concentration has to be limited. It doesn't has to be greater than what is already present in the solution. So this is how buffer action takes place, and sir, ultimately what we have to calculate in ionic equilibrium, the pH value. So how can you calculate the pH? Easy. Let's say for acidic buffer. Do you find any H plus ion concentration in acidic buffer? Yes, sir. Who does furnishes that H plus ion? Weak acid. So let's say if I have a weak acid HA, it dissociates as H plus and A minus. But this HA is in presence with a salt of this A minus with a strong base. Let's say salt is Ba, will be forming B plus and A minus. Because of presence of this much amount of A minus, its dissociation is further suppressed. Till you can, what will not change? Ka will not change, sir. So how can you write the value of Ka, sir? Ka will be equal to concentration of H plus ions into concentration of the conjugate. Acid has a conjugate base upon concentration of acid. You got that point? Now these all are equilibrium concentration. Sir, we have H plus ion concentration. So take that H plus ion concentration. So what will be your H plus ion concentration? It will be nothing but Ka into concentration of HA upon concentration of the conjugate base. Taking minus log. So minus log will be making it pH becomes equal to pKa minus log of HA upon A minus. I'm rewriting this statement. We have started our derivation from here, but I'm going here. We are rewriting this because I want you to learn this. It will be pKa plus log of, sir, plus it is minus. If I take this minus to the power over there, because log of A raised to the power B, so this minus will become plus log, and this will be reversed. So what is A minus? You tell me who will contribute to the concentration of A minus? Sir, A minus will be furnished by the salt. And one more thing, I am writing A minus only. Why? Because just like our previous question, sometimes the JEE question plays with you. It gives you a salt which furnishes twice of, maybe thrice of these negative ions. So therefore, I am not writing just because sometimes some references write concentration of salt, because this A minus is actually given by salt, because acid producing this A minus is negligible, 1. So whatever concentration of salt is present, that will be contributing towards the concentration of this conjugate base, which is the common ion. So what people write is concentration of salt. So suppose a salt, let's say calcium acetate is given. So calcium acetate 1 mole will be producing 2 mole of this. So what people do is calcium sulfate, if given 1, they write 1. That's why I'm not writing in the formula salt. What I'm writing is concentration of the A minus, which is conjugate base, upon concentration of the weak acid, because weak acid is dissociating negligibly. So whatever concentration is given, that concentration you have to put in this formula, and if you do so, you will get the value of H for an acidic buffer. So learn with me. pH of an acidic buffer is equal to pKa plus log of A minus upon HA. What is A minus? Conjugate base by salt upon HA is weak acid. Similarly, with the same symmetry, can you give me the pH of basic buffer? Definitely, sir. How? Using the same logic. For a base, let's say I have a base BOH giving B plus and OH minus. So its Kb will be equal to concentration of B plus into OH minus upon concentration of base. Now you have OH minus over here. So concentration of OH minus will be equal to Kb into base concentration upon the conjugate part B plus. Taking minus log, so it will be equal to POH will be equal to PKB plus log of this B plus will be given by the salt upon weak base. Now this I am not changing in form of pH because the pattern will change. What is the pattern? For acidic buffer you calculate pH. pKa plus log of salt giving that conjugate base, salt giving that conjugate, this is when acid is conjugate base, so salt giving the A minus upon HA. And what about basic buffer? POH is equal to pKb plus log of salt giving that B plus upon the concentration of weak base. Now, sir, if I have to find pH, 14 minus POH. Now, let's see some questions. All the exact same questions with logic. Although there are many questions which will be just formula based. You will be getting those in the PYQs. But I'm suggesting I have taken only few which requires at least some of discussion. So let's see. A student needs to prepare a buffer solution. The question itself is telling you the student needs to prepare a buffer solution. Okay, sir. What else? Of propanoic acid. So propanoic acid is a weak acid. So it's acidic buffer. And it's sodium salt, so it's with a strong base, and pH is given. Okay, sir, the question has given you. So acidic buffer formula, pH is equal to, acidic buffer formula, pH is equal to pKa plus log of the A minus given by salt. So what will be A minus? This is RCOO minus upon concentration of the weak acid. pH is given to you for pKa, K of acid is given. So pK will be minus of log of this Ka. What is Ka? 1.3 into 10 raised to the power minus 5 plus log of. Simple. What is A minus upon HA? Okay, A minus upon HA. This we have to find. So let's say A minus this ratio we have to find. Let's say this ratio is A. For the case of simplicity, why to write that? It is difficult to write, no? So log A. Just now we just have to calculate. So let me help because in these questions I'll be helping you with some calculations also because I feel I should. Now, how can you work on this, sir? Easily can be worked. How? Minus of log of 1.3 can become 13 and this is 10 to the power minus 6. What else? Sir, log of A into B is log of B. Log of A plus log B. Why I am saying B? Because 10 is power minus 6. Minus 6 can become this with this minus. It is 6 log 10, which is 1 minus log of 13. Now 13 can be broken. Whenever you find such a prime number, just go one step ahead or backward. 12 is a easier digit to be measured. So this approximation you can do. Because sometimes log value are not supplied, like over here not supplied. So they want you to do this mathematics. That's why I'm discussing mathematics, or else I would have said solve it. So what can you write 12 as? I'm taking it to be 12. So how can you write 12? 12 will be 4 into 3. 4 into 3 is 12. What is, now this you can solve. How? I'm just solving log first. So 6 minus log of 2 square minus log of 3. This is your answer, B. 4 into 3. Log A into log B is log A plus log B. Why not written plus? Because there's a minus. So 6 minus 2 into log 2 is 0.3 minus log 3 is 0.48, 0.5. So what is this? 0.6 and 0.5, 1.1. So 6 minus 1.1 will make it 4.9. Now, using this 4.9, now I know pK. So again, using in the equation 4 is equal to 4.9 plus log of the ratio that we have we need to calculate, we have marked as A. So this is the formula that I'm using, and over here I have just calculated log. So this is your answer. What is log A? Sir, log A becomes 4 minus 4.9 is 0.9. Okay, so there will be some, acha, when this goes to that side, it is minus 0.9. Calculations. So what is the property of log? When A will be equal to 10 raised to the power minus 0.9. Anti-log is not given. These values are also very typical. What to do? I'm helping you with a mathematical approach. Now, just make a note of it. I'm helping you with a mathematical approach. Just make a very good note of it. See, 10 raised to the power 0 is 1. 10 raised to the power 0.5 is 3.162. How do you remember, sir? Under root 10, everybody remembers. If you do not, please do that. So 10 raised power under root of 10 is 10 raised power 0.5 is 3.162. 10 raised to the power 1 is 10. What are you doing, sir? See, if I move 5 steps of 0.1, this is 0. So 10 raised to the power 0.1, 10 raised power 0.2, similarly 0.3, 0.4, 0.5. How many steps I have moved? 5. In those 5 steps, how much distance, how much value, how much number I have covered from 1, I have reached till 3.162. What's the difference? 3.162 minus 1. So it is 2.162. 2.162 divided by 5 is the value that you have gained after each 0.1 step. So my point is, sometimes that anti-log is not given. This is a very beautiful trick. Now, actually, if you divide 2.162, the difference, by 5, you will get somewhere around 0.43 dash dash dash. For me, it is easier that each 0.1 step has a value of 0.4 approximately. So 10 raised power 0 is 1. So what will be 10 raised power 0.1? 1 plus 0.4. 1 step is equal to 0.4. So this will be approximately 1 plus 0.4. What will 10 raised power 0.2 will be? 1 plus 0.4, 2 steps of 0.4, as in approximately 0.8. So this is how you should at least get an answer and tick whenever there is a options. Integer type question, it will not be working because there you have to give the precise answer. Although in those questions, anti-log will be given because no student can do that. Now, what about, sir, if it is having a value from 0.5 to 1, the contribution is different. You can see, because 3.162 becomes 10. So the difference is 10 minus 3.162. Divide by 5. Again, the steps will be 5 only. 10 raised power 0.6, 10 raised power 0.7, 0.8, 0.9, 1. So over here, from 0.5 till 1, each 0.1 step contributes 1.4. So 0.6 has a value of 3.162 plus 1.4. Similarly, 1.4 into 2, 1.4 into 3, reaching to 10. Sir, make note of this thing. This is very, very, very important. Now, mathematically, it will be of great use. See, I'm applying that use to you. This is A is equal to 10 raised to power minus 0.9. So let us calculate this. We know A equals the ratio that we have to calculate, A, 10 raised to power minus 0.9. So I can write it as, see, one integer I need. Whatever power it is given, you just approximate to the closest integer. What else you will be having? It will be something around from 0.1 till 0.9. Like if I take -1 over here, what should I take in the power over here? 0.1. Why? Because 0.1 minus 1 is minus 0.9. So mathematically we are right. And now we know the trick. 10 raised power 0 is 1. So for one step, 1 plus 0.4. So this is approximately 1.4 into 10 raised power minus 1. Now let us check. Okay, there are only options. So include the -1 to this 1.4, it will become somewhere around 1.4, 0.14. So do we have any option? Yes. 0.13, closest one. So this is how ABCD you will get your answer. Moving ahead. Now, the question says dissociation constant of acetic acid is given. Okay, sir. Dissociation constant as in K value is given. Okay. When 25 ml of 0.2 molar salt, sir, what is the salt? Salt of weak acid and strong base is mixed with 25 ml of this much molar acetic acid, sir. Okay, it's a buffer because salt of weak acid, strong base along with that weak acid. What buffer? Acidic buffer. The pH of resultant solution is, okay, pH is also given. So for acidic buffer, what's the formula? Sir, pH is equal to pKa plus log of concentration of A minus upon HA. The A minus given by salt upon HA. So pH is given out to be 5. pKa, that you have to calculate. Because you have to find, okay, pK it is saying it is something, oh, so okay, so K this. So let us take minus of log of X into, okay, X I'm taking this X as A. So of log of A into 10 raised to the power minus 5, this is Ka for me, plus log of. Now, the concentrations I need, sir, it is making a buffer. So, what is the moles of salt that you are adding as per the questionnaire? So 25 into 0.2. So salt, that is, this will be giving you A minus. So for A minus, moles is equal to 25 millimole into 0, molarity into volume. And for acid HA, moles added is equal to, again 25 into, okay, this is 0.02. 0.02, you got that. But in order to find concentration, we have their moles, but what will be the volume? Sir, this 25 plus this 25 will make the volume double, 50 ml. That's why I've taken milli ml only, because milli will get cancelled. So this has to be divided by the volume, which is now 50. So moles upon volume of solution. Solution has got the volume of this also and this also. So you can clearly see the volume, the concentration is being reduced to half. So for A minus, the concentration is 0.1. For HA, the concentration is 0.01. So using this calculative value over here, A minus is what? 0.1, this is 0.01. So this is 0.1 upon 0.01. It is basically log 10. It is basically log 10. So log 10 is 1. So this is 1. 5 minus 1 becomes 4. So 4 equals, or minus 4 equals log A, because this minus I've taken on after 4 minus 1. 5 minus 1 becomes 4. This minus I have given over here. So this is minus 4. Then applying property of log A plus log B. Log of 10 to the power minus 5 is minus 5. So this is minus 5. Minus 5 going over here will become plus 5. Plus 5 minus 4 becomes 1. So log A becomes 1. If log A becomes 1, then this is base 10. So what is A? A value is 10. Simple question, but this division factor has to be taken into account. Moving ahead. Okay, again a buffer question. A liter of buffer solution contains 0.1 mole each of ammonia and, okay, ammonia in water is ammonium hydroxide. This is ammonium hydroxide, although written ammonia, but it is ammonium hydroxide because ammonia in water is ammonium hydroxide. So that's a weak base for you. And this is a salt of the similar weak base with a strong acid. Strong acid is HCl. That's why Cl minus. So again, it's what type of a buffer? Basic buffer. On addition of 0.02 mole of HCl. Now, the buffer action that we just did, we again have to take that into account. See, what is the buffer action we just understood, sir? NH4OH will be dissociating to form NH4 plus and OH minus very slightly. How much mole of ammonia is present? Sir, 0.1. So how much it will be dissociating? Very less, because its Kb will be, so it is nothing but 0.1 only, because weak base will be dissociating negligibly. So this is 0.1 only. So from where this NH4 plus will be coming? From the salt. What is the salt? NH4Cl. Okay, because it is strong electrolyte, so completely dissociating. NH4 plus Cl minus. So what will be its concentration? It will be completely gone, forming them each. That means 0.1 mole of this is also taken. So this is also 0.1. This is also 0.1. Its concentration, I'm not interested. I'm interested in this because it's a basic buffer. So do you know for basic buffer what's the formula of pH? No, sir. For basic buffer, keep this in mind. pOH is calculated. pOH is pKb, given pKb is 4.745. This is your answer. Now, 4.745 plus log of. Now, I need the concentration of the ion and then upon weak base. What is the ion? This is the ion. Is the concentration of ion this? No. Why? Because some buffer action is also taking place. Where, sir? The reason I have written it like this, because I need to show you the buffer action which we started with. They asked, beautiful question in 2023. Before that, such questions were not asked. Before that, only this equation is called Henderson-Hazel-Balch equation. So directly it was used. But now these days, see. So if I'm adding 0.02 mole of HCl, obviously it is lesser because it is 0.1 and the added is 0.02. But if HCl is added, H plus will come. How much H plus will come? 0.02. So if H plus is introduced into the system, will it be left behind? No, sir. It will be neutralized. By whom? Plus will go to minus. Who is minus? Sir, OH minus. Because H plus will be attracted by OH minus and what will be formed? Water. H plus, if I'm adding H plus ions, these H plus ions will be attracted by OH minus ion coming from weak base, although that weak base is dissociating to negligibly, not at all. But because it is present in excess, it will keep on dissociating slightly till the added H plus are killed. So what happened is, because I have added 0.02, so 0.02 moles of NH4OH will be dissociating and forming these OH minus ion, which will be killing this H plus ion and forming water. So my point is, at the new equilibrium, this concentration will be 0.01 minus 0.02 because 0.02 H plus will be forcing NH4OH to decompose. So its new concentration will become, its new concentration of NH4OH will become this minus this, that is 0.08. Now, sir, if it is, this is NH4OH has been dissociating, sir, apart from OH minus ion, it will be creating NH4 plus also extra, which initially we were not calculating. Why? Because initially, because of this common ion, it was not at all dissociating. Now it is how much? 0.02. So if 0.02 more of NH4 plus is produced, so via simultaneous equilibrium, its concentration will be added by 0.02. So its concentration will be 0.12 and it will be 0.08. This is the catch, a very beautiful catch which this JEE question used. Although for mains, it is for the first time they used, but this is my moral responsibility to tell everything that has been asked in mains. So what will be the concentration of the ion? 0.12. 0.12 upon what will be the concentration of the weak base? Sir, it has been decreased, 0.08. So what will be your answer? POH is equal to 4.745 plus log of 12 by 8 simply. So 43 by 2. Now you can solve it. What is log 3 or given? Log 2 given, do not approx, take this value because the answer that you have to mention is in 10 to the power minus 3. So you have to be precise till 3-4 places of decimal. So you can see the answer also 9059. And this is what pH. When you will solve this exactly, this is log 3 minus log 2. Put these value, add, subtract, you will getting POH. But you are asked pH. So pH will be 14 minus POH. So mathematics plus minus you again have to do. Now this is basic mathematics that you can attempt. So after finishing this buffer, let us move ahead. Yes. So before moving to the solubility side of ionic equilibrium, let us discuss one more question, because over here I am relating titration with whatever we have studied. Titration we already spoken about in the mole and redox part of it. Let us speak some more of it while linking it with ionic equilibrium topics. So over here, you are supplied with 50 ml of 0.1 molar weak acid, acetic acid, and the same concentration 0.1 molar NaOH is taken. The question is asking you, when 25 ml of NaOH has been added during titration, you have to tell me the pH of solution. pK of acetic acid given, some log values are also given. So a photo view of the titration. Let's say because we are adding NaOH, so I am taking NaOH in the burette. So this is NaOH. What concentration is given? 0.1 molar. It will be filled till the brim. So this will be marked as 0 ml. Whenever you'll open the tap, it will start coming down. You can read the volume. What is taken in the beaker, in the conical flask? Sir, acetic acid. How much concentration? 0.1 molar. What was the volume? I guess 50 ml. Let us just check. Yeah, 50 ml, 0.1 molar. You tell me what's the reaction will be happening, sir. When this weak acid will say hello to the small base, they'll form salt of the weak acid and strong base along with water. At time t equal to 0, how many, what is the, because 50 ml is present, but when the volume will start flowing down, volume will increase. So concentration, you have to calculate with the total volume. So let us calculate moles, because volume is also ml, that is also flown in ml. So let us calculate millimoles. What is millimoles? Some molarity into volume. So 50 into 0.1 is, so you are given with 5 millimoles of whom? Of the acid already present. Initially, when you have not supplied any NaOH, now you tell me, let's say if I am putting a digital pH meter over here and you are an educated JEE aspirant, so you tell me what this digital pH indicator initially will be giving you. Sir, initially this pH indicator, what will be its value? You are educated, you tell me. It will be of the pH of a weak acid, because just the weak acid is present. What will be its formula? pH is equal to half of pKa minus log C, that of a weak acid. C concentration is 0.1, K is given, so initial pH also you can calculate. Question may ask anything. Now if you start filling NaOH, how much NaOH you have poured? 25 ml, and then you close this burette. So if 25 ml has flown, what moles has flown? 25 into 0.1 is 2.5 millimoles. So when they will react and reach equilibrium, what will be done? So 1 reacts with 1, so 2.5 reacts with 2.5. So this will become 0, and 5 has 2.5 of this has reacted. So how much of it is left? 2.5 still remaining. 1 forms 1, so 2.5 will form 2.5. Water, although that water will also be found, but pure solid, pure liquid do not impact. So why take water? Why bother? Now, sir, what is this? This is a buffer of a weak acid and it's salt with a strong base. What is pH of a buffer? Of an acidic buffer? Sir, it is equal to pKa plus log of concentration of this ion given by salt, so CH3COO minus upon of the weak acid, as in CH3COOH. Remember Henderson's equation? Now, this is also 2.5, this is also 2.5, getting cancelled. So, log 1 is 0, so pH is equal to pK. So, this is your answer. Sir, but this is okay. I'm just giving you the pH ranges also. Initially, it was of a weak acid. Over here, it is a buffer solution. Now, let's say I'm adding. Now, the question has just asked you this much. You can definitely find the answer. Already we found the answer. Now, what addition I'm doing this to this concept is, let's say if question asked 50 ml of NaOH you have supplied. So then also we know 50 ml as in 5 millimoles. So 5 becomes 0. So all 5 millimoles of salt will be formed. So salt in water, not a neutral solution because not a neutral salt. It's a basic salt. So what will be the, in that case, okay, that question is not asked. I'm just making one step forward to the sense. JEE can do anything. I'm just giving you all the concepts. So if 50 ml would have been brought, sir, it will be salt. So it will be a case of salt hydrolysis. So what will be the pH of a basic salt in water? Sir, we from salt hydrolysis also we remember basic salt. So 7 plus. What is the addition factor? Half of pK of the weaker part, which is acid in this case, plus log C. Now there is a mathematical thing you have to do. Here, because it was getting cancelled, so volume, we have just taken, these are moles, but this is concentration. We have not bothered about volume because volume of this, these are present in same solution. So upon V will get cancelled. But if it is a salt, you tell me what is the value of C? 5. Because if 5 millimole react with 5 millimole, 5 are produced. So will you put value 5? Concentration is moles per liter. So this will be equal to, if this is when 50 ml NaOH is added. This is not your question. Your question have got your answer. So solve it. 7 plus half of, you just tell me, pK will also be given. You just tell me the value of C. Sir, 5, if 5 react, 5 will be formed. 5 is the millimole. What will be the volume in ml? Because milli will get cancelled. So 5 millimole, I have no problem in writing 5 milli, because that milli thing will be cancelled if I put the total volume in ml. What is the total volume? Sir, 50 was already there. 50 you have again added. So what will be the total volume? Sir, it will be 100. So value of concentration will be 5 upon 100. Students miss this and say, sir, we did this much mistake. This is not this much, this is blunder. So moving ahead, you got this logic. Now, moving to the last topic, and a very loved topic by JEE. You will get many questions from, sorry. In fact, Ionic Equilibrium in mains, you get a question from solubility of salts only. Sir, what is it? Very easy. Salts are generally ionic compound. Ionic compound generally ionizes. But we know some from Fazan's rule also, we know that salts may also have covalent character, like generally the D block cations forms covalent salts. So if I am covalent salt, I will not dissociate completely. I will be a weak electrolyte. So those weak electrolytes, what they do? They dissociate weakly. The value of Ka will be of the order of 10 to the power minus 3 and sometimes much lesser. So these salts will not dissociate. So practical world, experimental world have made a benchmark. They say if any salt has a solubility greater than 0.1 molar, as in if in 1 liter solution, if the salt is getting dissolved to an extent of greater than 0.1 moles, it is a soluble salt. If its solubility is between 0.1 to 0.01 as in 10 to the power minus 1 to 10 raised to the power minus 2, it is slightly soluble. But if your solubility is even less than 0.01, that is 10 to the power minus 2, I will call you a sparingly soluble salt. That no, you go to your home, you are not dissociating. So that's the definition of a sparingly soluble salt. Now, the very famous example of a sparingly soluble salt is AgCl. It is AgCl. AgCl is a beautiful white colored precipitate which very sparingly, very negligibly dissociates and forms its constituent ions, which are these two ions. It is basic AgCl, so 1 ions are given. So let's say I have AgCl over here. Now we know AgCl is what type of salt? It is a, let's say this is a solution and this is AgCl. What type of salt is AgCl again? Sir, it is a sparingly soluble salt. But through Ostwald dilution law, we know if we increase, I've filled the solution with the water till this level. So for this much of salt, sir, this water is infinitely. So even if a salt is sparingly soluble, if you increase the volume of water at infinite dilution, its solubility will increase. But still, let us say some of its ions are forming. So it dissociates and forms some of Ag plus and some of Cl minus ions, some of Ag plus and a few of Cl minus ion. When it reaches equilibrium, can you write the value of K? Yes, sir. K will be equal to concentration of cation raised to the power 1 because stoichiometry is 1, concentration of anion raised to the power 1 upon concentration of AgCl. Sir, but this concentration is not at all getting dissolved. So this is also constant. So constant into constant becomes a new constant, just like that we did for Kw of water. So instead of Kw, this constant into this constant, now we are referring this constant as Ksp, which is the solubility product or solubility product constant Ksp. So whenever salt is sparingly soluble, generally question offers their Ksp value. So with that you can understand it's a sparingly soluble salt. Now, in the chemical equilibrium side of the equilibrium, what we said, this K is equal to this. K is equal to this concentration. K depends upon this concentration. No. This concentration is the value at equilibrium. This was termed as reaction quotient. At the time of equilibrium, this ratio adjusted its value in such a way that it becomes equal to K. So Q approaches K. So in case of ionic equilibrium, we will not say it, we will not nomenclature wise, we will not name it as reaction quotient. We are giving it a new name because these are product of ions. So we are calling it as ionic product. Not this thing, this thing will be gone, but if you take this or leave this, doesn't make a difference because it's a constant. But a constant has, we have given a name Ksp, solubility product or solubility product constant. And to these ionic concentration multiplication, we are referring as ionic product, just like Q of reaction chemical equilibrium. So if I have a saturated solution of a sparingly soluble salt, so some of very minute of salt must have been dissolved. So nothing is happening, concentration is constant, whatever Ag plus Cl minus ion are allowed as per the value of K, it will be there and rest will be in the precipitate form. No more concentration change is happening because it is equilibrium, and at equilibrium Ksp is equal to ionic product. That value will definitely be equal to the value of K. But if I am supplying extra Ag plus ion from outside, let's say I can do that. So if I am supplying extra Ag plus from outside, let's say I am adding silver nitrate. So sir, Ag plus ions will increase. So concentration of Ag plus ion will increase, then concentration of this Q ionic product will increase. So if ionic product is forcefully increased by the value of Ksp, reaction quotient approaches K. So this will be thought of like a ball. This lowest point is represented by the value of K, here Ksp, and because you have increased the ionic product, so reaction has reached somewhere around here like Q. So where the ball will flow in backward direction. So backward reaction will take place. That means the ions present in the solution will be forced, attract each other and form what? More and more salt. So they will be getting precipitated till what? Till again equilibrium is achieved. So if such a scenario mathematically comes, what you will say PPT formation takes place. Similarly, by some means, if I reduce concentration of these Ag plus and Cl minus ion from here, if I reduce the ions present over here, let's say in the picture view, we said, let's say, for example, these 4 ions are allowed. If I remove this Cl minus ion through some means, if I remove this Cl minus ion, the ionic equilibrium, the ionic product becomes lesser. So ionic product becomes lesser than the value of Ksp. So this will be a case where this is K, but ball, that is Q, that is ionic product, has become lesser. So where the ball will go? It will go to forward direction. That means more salt will be dissolved. So some of the salt will be said, hey, ions concentration got decreased. You come out. 1 molecule, 2 molecule, you come out and you furnish more Ag plus. You are allowed now, although you are sparing soluble, come. So in English, you refer it as dissolution takes place in such cases. So this is the theory that we needed to talk about, although this is a very, people find it very difficult, but I guess you must have, because I have given a pictorial view of whatever I am saying. I guess it is much clear to you, but what question is asked? The question is much easier than what we have discussed. Sir, please frame something for us. This I've already discussed, so I'm removing from this side because I thought I'll not be getting space to write that, but I got that. So now this is what a general form you can make. Let us take, I have a salt, a general salt, because over there AgCl stoichiometry was 1:1. So here I'm taking a general case, AxBy. So what amount of cation I am having? X. What amount of anion I am having? Y. Let's say S moles per liter is the solubility. Some salts at temperature T, some of the salt will be dissolving. What moles? I do not know. So I'm saying S moles per liter is your S is a variable. So if one dissociates, if one of molecule of this dissociates, X and Y are formed. If S, capital S dissociate, X, S and Y, S are formed, the stoichiometry mole concept. Can you write Ksp? Yes, sir. Concentration of ions raised to the power stoichiometry. What is concentration of cation? Xs. What is concentration of anion? Ys raised to power X raised to power Y. So this you have to remember. X raised to the power X into Y raised to the power Y into solubility raised to the power X plus Y. Bingo. If you do that, you can directly make questions. Show us, sir. I have given few. There are thousands. There are many questions. You will get that in practice sheet and your PYQs. These questions, I mean, I've just taken few examples. A lot of questions from this area comes. Now, oh, this is an advanced question. What does it say? You have the salt. You tell me. By just looking at the salt, 1 raised to the power 1 because X is 1, 2 raised to the power 2 into solubility raised to the power 1 plus 2 is 3 is equal to Ksp. Some value will be given, some value will be hidden from you. What is given over here? Solubility, okay, this is value of S. What you have to do? You have to calculate solubility product, Ksp. Just do the math. Giving you more examples. Everything is same of that sort. Now here the salt is A3B2. So 3 raised to the power 3 into 2 raised to the power 2 into solubility raised to the power 3 plus 2. 5. But here salt has a molar mass m and solubility is x gram. We have taken moles. So write that concepts moles. What is S? Sir, it is moles of solute. What is moles of solute? Weight of solute upon molar mass of solute. Per liter volume is 1 only. So instead of S, what can you write? X by m. So this is X by m. So they are saying Ksp is this. Okay, sir. S by m we have. Raised to the power 5 we have. So what is value of A? Multiply this. This is our answer. Now, again, this is also again an advanced question. This is sir, you are saying this for salt. Magnesium hydroxide is a base. Any species can, if the question is asking you, any species can become a weak electrolyte. So cation is Mg plus 2 and anion is OH minus ion. What you have to do? The same thing. So 1 raised to the power 1 into 2 raised to the power 2 into solubility raised to the power 3 is Ksp. Okay, solubility you just have to take, instead of S, take X. So this is, I mean, you do not have to move your pen. This is 4x cube. This is also an advanced question. And such questions obviously directly is asked. Same 3 raised to power 3, 4 raised to power 4, solubility raised to power 7 becomes KSP. Do the math. These are all practice questions for you. Again, advanced as magnesium hydroxide, they just changed magnesium to calcium and gave a value. They had said S, they are giving some value. So do the math. Same 4x cube KSP. Last, same question. 1 raised to power 1, 4 raised to power 4 into solubility is S raised to power 5 becomes KSP. Just have to relate S and KSP. So these are the questions that you get a lot in JEE mains. Moving ahead. So let us use whatever logic we have studied till date regarding solubility. And actually, I told you, actually some people, bad people, they do what is, do some simple logics, very simple logics. What they start doing is, they start making topic out of it. Like I have written selective precipitation. Okay. Selective precipitation. Now, what is selective precipitation? Nothing's a logic which we have studied. We know if ionic product, as in the reaction quotient Q of chemical equilibrium, if concentration of ions are made in such a way that the value increases the value of its allowed KSP, then precipitation will take place. So selectively, if you are given 2 or more salts and you are asked which will be getting precipitated first, can't you tell that, sir? It's simple mathematics. But I'm telling you that. So it's a question. It's a JEE question. So these were all advanced topics, but mains have included. So I'm discussing. But actually, if you like, if I've given this topic first and then given the question, then even I'm bad. What I'm doing is I'm talking about the question and then generalizing it to a logic which we already know. Now, for example, the question says you have a solution is 0.1 molar in Cl minus. Okay, so you have Cl minus ion coming from some solution having 0.1 molar concentration, and you have this much okay, this is 10 raised to the power minus 1 and this is 10 raised to the power minus 3, because 0.0 I forget. So this is 10 raised to the power minus 1, that is 10 raised to the power minus 3. This is Cl minus and this is CrO4 2 minus. Okay. Solid AgNO3 is gradually added to it, okay, to the solution. Solid AgNO3 is added. AgNO3 will do what? AgNO3 will give Ag plus. So what is the case over here? In a solution, you have 2 different ions. So this solution, you have Cl minus also, you have CrO4 2 minus also. Their concentration is 10 to the power minus 1 and their concentration is 10 to the power minus 3. Okay, sir, this we know. And from the top, what are we doing? We are adding silver nitrate, which will furnish Ag plus and nitrate ion. Simple, sir. The word problem is the problem. Now, solid, okay, solid AgNO3 is added. So, solid AgNO3, because I know, you should also know, AgNO3 is a soluble salt. So, when solid AgNO3 is added to a solution, it will dissociate and form Ag plus and NO3 minus ions. You just have to say that volume does not change. Volume, if a solid is placed, volume is increased, but maybe we are using that small amount. So, the question is saying you have to consider volume is not changing. Okay, sir, not changing. KSP of AgCl is given. Okay, that means Ag plus coming from the salt will be attracting CrO4 minus, CrO4 2 minus ions also and Cl minus ions also. And forming what? Forming this Ag plus will be attracting Cl minus ion. Come, where are you going? So, why I am writing not an equilibrium sign? Because this is forming. This is a solid, a sparingly soluble salt. How I am confident it's a sparingly soluble salt? Because its KSP is given and that value is 1.7 into 10 to the power minus 10. So this is reverse reaction because KSP is for solubility. So I'm just writing the value. Its KSP is given to be 1.7 into 10 raised to the power minus 10. And of the other one, Ag2CrO4, it is 1.9 into 10 to the power minus 12. The other has a KSP, let's say I'm saying KSP dash 1.9 into 10 raised to the power minus 12. So this is 1.9 into 10 raised to the power minus 12. This is for what? This is for, okay, for this I'm writing that same equation only, which is Ag2CrO4, giving you twice of Ag plus along with its KSP. I'm shifting because I need space, plus CrO4 2 minus. So now we very well know, sir, for this reaction, although for the reverse reaction I have this value of KSP. So, but this Ag plus will be interacting with CrO4 2 minus also and Cl minus ion also. Now question is asking who will precipitate, which is correct, as in if you see the option, AgCl precipitating first, AgCrO4 precipitating first, and the reason why it is precipitating. So for this theoretical question, you need to know complete English about the mathematics side of the question. So let us first do the maths. Although question is not asking maths, but the theory is designed, that is a good question. So if I say, sir, if these ions are produced when AgCl is dissociating, because I was not feeling comfortable, because some of you might get confused that this K, now we know that this K is for this direction of equilibrium. So we have these two equations, right, sir? Now what else? Can you tell me what will be the allowed Ag plus concentration, because Cl minus ion is already there? Because Cl minus ion I do not wish to get from AgCl, because AgCl is not even present over here. Cl minus ions are already there. So the KSP value, which is 1.7 into 10 raised to the power minus 10, this value will allow ions. So how much silver ions are allowed? Ag plus equilibrium, this much is only allowed. How many Cl minus ion are not furnished by them. You will furnish, but what is your allowed value? No matter what is your allowed value, Cl minus ion are already present. How much? 10 raised to the power minus 1. So this is 10 raised to the power minus 1. So can't you see what is Ag plus required? So Ag plus required in case of AgCl becomes 1.7 into 10 raised to the power minus 9. This much Ag plus is required in form of AgNO3. If Ag plus added is this much, then AgCl will start precipitating. When this will start precipitating, because again CrO4 2 minus ions are already there. If Ag plus added, what Ag plus amount should be added? You will use its KSP, which is 1.9 into 10 raised to the power minus 12. So for this, how much Ag plus is required? Here Ag plus will be squared. That's why I've written the same scenario. But over here, this salt is getting precipitated. That's why I've first written the opposite reaction. But KSP is defined for this reaction. If you reverse the reaction, KSP will become 1 upon that. So that's why I've again changed the reaction, because some of you might get confused. So this is Ag plus squared into CrO4 2 minus. But sir, this CrO4 2 minus is not in our hand. This is already present. How much? 10 raised to the power minus 3. So I am replacing this value with 10 raised to the power minus 3. So this will allow how much Ag plus ion? The under root of 1.9 into 10 raised to the power minus 12 and minus 3 makes it minus 9. So this is 10 raised to the power minus 9. I'm making it 19, so it will become 10 raised to the power minus 10. So this is 19 for me. So I'm just comparing. This is 10 raised to the power minus 10. So what will be the value? 10 raised to the power minus 5 into under root of 19. So somewhere around 4, 4 is 16, 5, 5 is 25, somewhere around 4.5. Although this is also not required. Why? Because its power is 10 raised to the power minus 9. Its power is 10 raised to the power minus 5. Which salt requires more Ag plus to get precipitate? This 10 raised to the power minus 5 is much larger. This is much smaller. So if you are adding AgNO3, who requires lesser amount? If you are adding AgNO3, Ag plus will start coming 1, 2, 3, 4, 5. Who require lesser? Sir, AgCl requires lesser Ag plus. So this amount is lesser. So AgCl will be precipitated first. And when the value of Ag plus ions reaches this value, then AgCrO4 will, Ag2CrO4 will start to get precipitated. So let us go to the theory. AgCrO, no, A is wrong. Ag precipitates first, this is also wrong. AgCl will precipitate first, C is right. As the amount of Ag plus needed to precipitate is low, yes, definitely correct. Do not have to read option D, but let us read. AgCl precipitate first, this is right because it's KSP. KSP has nothing to do with who will precipitate first. Who will precipitate first is decided by whenever their ionic, whatever we have studied, whenever their ionic product becomes equal to the value of KSP. So your KSP may be anything. Moving ahead. So this is a good question actually. Now moving to the other topic, the last topic of ionic equilibrium finally. Cases of solubility. Sir, what are the cases? Whatever solubility we did right now is in pure water. Like for example, if I take the simple case, because that is loved by JEE, the case of AgCl. AgCl has a solubility S, remember? So in pure water, how can you calculate its solubility? Sir, we have already calculated. S square is equal to KSP. So this solubility S was in pure water. So in pure water, the answer would be under root of KSP. If solubility is asked, like many questions have been asked. This we done, sir, why telling again? Because if a common ion is present, again, sir, common ion, sir, it's a sparingly soluble salt. If a common ion present, it will dissociate to a much lesser extent. That is what I'm asking you. Suppose I already have AgNO3 in solution, 0.1 molar. Now, if I add AgCl, AgCl is a weak electrolyte. Anyway, it was present in pure water. It was not ready to dissociate. Now, in presence of this much amount of Ag plus, will it dissociate? No. But still, some of it will dissociate? Yes. So, the new solubility you have to calculate. So, this is in presence of common ion. So, can you tell me the new? Sir, this is the same thing. So, beta, when you get the logic, everything appears same. Let's say its new solubility is S dash. So S dash of this will be formed, S dash of this will be formed. But what never changes? KSP, so that will equilibrium constant. So what will be the concentration of Ag plus ion at equilibrium? Multiplied by what will be the concentration of Cl minus ion at equilibrium? Equilibrium I am writing by deliberately. Why? Because sir, Ag plus is not furnished, it is dissociating very slightly. Ag plus concentration will be given simultaneously, S dash plus 0.1. And I know this S dash is negligible in front of 0.1 because 0.1 is a value which is valid for saturated, for salts that dissolve, the NCERT page. If value is lesser than 0.01, then you are called sparingly salt. Sir, this is a huge concentration. So what will be concentration of, actually I have just write it is Ag plus is plus 0.1 and S dash plus 0.1, S dash plus 0.1 is approximately equal to 0.1 because 0.1 when we'll calculate, you can calculate S dash, you will get some questions on this sort, you will see S dash values will be some 10 raised to power minus 7, minus 8, so 0.1 10 to the power minus 1 is much larger. So what mathematical edge you will get for Ag plus, instead of writing this or else it will make a quadratic. So instead of S dash plus 0.1, I am directly putting this value which is 0.1 raised to the power 1. And over here S dash, this will give you the new solubility. So it will not be under root of KSP. The solubility will be KSP upon the concentration of the common ion added from the strong electrolyte. Now, the same question, I guess, this was a JEE 2021 question, the same question. Only the logic, the basic logic changes. What changes, sir? Solubility of cadmium. Cadmium sulfate. What cadmium sulfate is? CdSO4 when dissociates forms Cd plus 2 and sulfate ion. Okay, sir. Solubility in, okay, in pure water, its solubility is given. So in pure water, its solubility is S and S. I do not have to write this only also. 1 is to power 1, 1 is to power 1 into solubility raised to the power 1 plus 1 as in 2. So solubility square, I'm directly writing it. It is equal to KSP. So they are not given, initially they have not given the value of KSP. They are directly giving solubility in pure water. So value of S in pure water is given. So that you may calculate KSP. They are making you do 2 steps. So KSP you calculate. What is KSP? Square of this value, as in 64 into 10 raised to the power minus 8. This is value of KSP. Now it is saying its solubility in 0.01 molar H2SO4. Now H2SO4 will give what? H plus. We do not care. H plus is not a common ion, but it will give sulfate ion. One molecule will give one sulfate ion. So 0.1 molar will give 0.0, I mean 10 raised to the power minus 2 molar will give 10 raised to the power minus 2 molar of sulfate ions. So the new solubility, let's say S dash and S dash, it must be decreased because see 10 raised to the power minus 8, anyway its solubility is very less. In presence of common ion, its solubility will be much decreased. So sulfate will be coming from this also, but this will be a more smaller negligible value, and simultaneously sulfate will be contributed by this also, that is 0.01. Again, KSP value will not change. So 64 into 10 to the power minus 8 will not change. Concentration of CD plus 2, which is your new solubility, S dash. This is new solubility in common ion. And instead of this, I'll just write 0.01 because S dash is negligible. This is how you do such questions. So moving forward, let us go to the next case of solubility. It's also just a theory. A basic common sense will do. The world make you fearful with the statement, with the term simultaneous solubility. It is nothing already seen. Suppose in the previous case we had common ion coming from a strong electrolyte. Now if I have AgCl solid, so it is sparingly soluble salt. Now you again bring one more sparingly soluble salt. So what happens is AgCl solid, when going in water, getting dissociated to a very small extent to Ag plus and Cl minus ion. How much of it will be dissociating? KSP1. So this KSP1 will be calculated by concentration of Ag plus into Cl minus ion. That's it. Now what I am doing right now is AgBr solid is again getting dissociated and forming Ag plus and Br minus ion. Its solubility will also be decided by the value of its solubility product KSP2. If it would have been produced by a strong electrolyte, its dissociation would have been suppressed. Still it will be suppressed, but to a very lesser extent. Now what question asks is, let's say its solubility is S1. So S1 and S1 amount of these are formed. Let's say its solubility is S2. So S2 and ST amount of these are formed. What is the simultaneous solubility? For Ag plus, you will have at equilibrium, the value of solubility will become S1 plus S2. So how can you relate this value of S1 plus S2? Sir, KSP1 will be equal to S1 plus S2 into S1. KSP2 will be equal to again S1 plus S2 into S2. Divide KSP1 by KS2, KSP1 by KSP2. You will get the value of S1 and S2. Moving ahead. So let us move forward to the last topic. This we have already done in chemical equilibrium. While discussing chemical equilibrium, I deliberately took this because again, sir, after learning so much, now we are discussing this topic, but in chemical equilibrium, we didn't know about ionic equilibrium because if you know with basic, over there also we have completed such questions. So this I want you, because this I have done deliberately, go to chemical equilibrium and see to that chapter again. You will be revising that also, and now that complete chemical equilibrium will be much more easier for you to understand if you want to do it, or else whatever we have done is more than sufficient. Now, solubility of AgCl in ammonia solution. Sometime what happens, like for AgCl in solid, AgCl solid when goes to water dissociate partially to Ag plus and Cl minus ion. With this we know. Sometimes for AgCl it happens all the time that Ag plus is hugely loved by ammonia. Why? Because ammonia forms a soluble complex with silver ions. Silver and D block cations are supposed to form complexes. So obviously, sir, if I will write the value of equilibrium constant for this reaction, it will be value of KSP. KSP will be equal to concentration of Ag plus into concentration of Cl minus ion. Sir, if I write equilibrium constant for this reaction, this is known as formation. It will be an equilibrium constant only. I am just telling you because theoretically we say that it is formation constant, Kf. There was a question also in chemical equilibrium. So formation of this complex will be equal to, I am referring to it as complex so that I may write it easily. So formation of concentration of complex raised to the power 1 upon concentration of silver ions upon concentration of ammonia, the whole square. So this gives the value of Kf. Now again chemical equilibrium logic, if you add two reactions, Ag plus got cancelled. Now the reaction that you just got, can you tell me what will be the value of equilibrium constant for this reaction, Kc? Yes sir. Concentration of product, which is the complex, into concentration of Cl minus upon concentration of pure solid, pure liquid do not impact state of equilibrium, so leave it, upon concentration of ammonia squared. So this becomes the value of Kc. What question does is, it hides some of this data and asks you another. So over here also what is happening is, AgCl is a very weak electrolyte, does not dissociate, but when this Ag plus is removed from its equilibrium, Le-Chatelier's principle will shift this equilibrium forward direction. How it is removed? You are taking its reactant, its product as a reactant, who is taking its product as a reactant, ammonia, and forming this complex. And because the value of Kf is very large, so this will be formed. If this will be formed, then this has to be dissociated, because if it is a weak electrolyte, some amount of solute, some amount of ions it need for its K to become equal to Q. So this is how a sparingly soluble salt can also be forced to dissociate partially or maybe completely. Moving ahead to the last question. We have done a question, just a theoretical question also came in 2022. The solubility of AgCl is in maximum. Now you have to tell me, we have discussed, if even a weak electrolyte can be forced by dilution also and by doing n number of things also. So if you have AgCl, you know, sir, AgCl never dissociates. We have discussed so much about AgCl, it dissociates very partially. So it's a reversible reaction. Very small amount of these are happening. You have to tell me solubility of AgCl will be maximum in what? Okay. KCl, strong electrolyte will give Cl minus ion. Cl minus ion is a common ion. This will force AgCl to be dissociating less. This will also give Cl minus ion. It is a common ion. It will also force to go in backward direction. Both our concentration are same, so both will force to the same extent. So in these two cases, its dissociation will be further suppressed. This is also the same concentration and it will produce Ag plus ion. So this will become the common ion for option C. Concentration is also same. So again, AgCl will be less suppressed because common ion is already present. So instead of all this option, I'm just happy with, even if I'm weak electrolyte, I'm happy with ionized with water, pure water. So to pure water, they are saying deionized water. So obviously, this is right. So moving ahead, I guess we are done. I have missed that thank you slide, but still it's good, because you do not have to take these notes, all these PDFs you will be getting just go to the description box, download the PW app, and you will be getting that, all the content, the sheet, the practice sheet, that is very important after this, because if you practice, then only these theory will be get into your head, and you can download it from there. So we'll meet in the next lesson. Thank you.